we recently announced that we are also entering the robotaxi market with a very different technological approach where a single brain can actually really drive all these different form factors. So it's a pretty exciting time for us.
And what do you see as the frontier problems that you're still solving on autonomy today?
Yeah, so if you look at really what you want is a physical AI platform that can truly generalize, because these are physical AI robots that no matter what happens on the road really need to work and do the right thing.
안녕하세요.
So what we're really doing
마인드님은
now is
진짜
just scaling the
지금도
technology,
빨리
deploying
오시네요.
commercially,
대단하시네, 진짜.
driverless with our
일단 소리
OEM
밸런스
partner Volvo,
한번
which is what you're
보고요.
going to see next, or one of the next things from the company. And
아직
really you
키노트가
will see
시작 안
our beautiful
했으니까.
new robotaxis soon. So, we have a partnership with Uber where we are going to deploy a minimum of 25,000 robotaxis. So this is really the next level of scale that you're going to see over the next couple of years.
What, 25,000 across the world in certain areas? What parts of the world?
Yeah, great question.
Okay.
So we haven't unveiled yet what the first market is.
걔는 이제 자러 갔죠. 저만
Definitely
있죠, 오늘은.
we plan to be a global company. Now we will start with the
소리가
markets
근데
that make
뭔가
sense, right?
조금 노이즈가 있는 것
But yeah,
같네.
you will see at some point, technology from Wabi,
저는
even
저기
beyond,
엔비디아 현장에서 나는
say,
건가?
self-driving and
그런 것 같기도
transportation,
하고.
which is, thanks to this physical AI platform, a really exciting time to bring robotics everywhere.
오케이. 지금 이제 키노트 전 사전 쇼 하고 있는데 파텍이 나와 있죠 지금?
A bunch of different very real-world domains, from oil and gas to semis companies. When we think about the models we have today that are quite by nature approximate, like what's the room for that?
이
and our
사람
foundation
노프라이어
models
아닌가?
today and traditional
그렇죠.
physics-based
노프라이어
simulation.
나오는 사람이죠.
Well, maybe to start with, like we're building a new engineering simulation
소리를
software
조금
stack, one that
줄여보겠습니다.
is trying to move the world of a lot of industrials
이렇게?
and the engineering, manufacturing, production that
내가 안
happens
들리니?
within these companies to simulation by inference. So, to
여기
your
좀
point,
줄여야겠다.
today a lot of engineering and being able to predict physics and behavior runs through numerical simulations.
자,
They are approximate. We
마실
only
거를
understand
잠깐
so
넣어도.
well the phenomena that are being predicted, and better improving those runs.
그러게 오늘 뭐
through
있을까요? 진짜
first
오늘 뭐
principles
있을지
scientific
전혀 모르겠네.
discovery. But they're also incredibly slow. And so, being able to move that to inference means that, we can do prediction anywhere between
황
10,000 to
선생님은
close to a
아마
million
좀
times
이따 오실
faster.
거기 때문에
But we can also sort
잠깐만.
of embed, that very fast prediction into places where you can't do high fidelity simulation. So in control applications, and the rate of improvement now
이렇게
for us to be able to
영상
do
소리를 좀 더
simulation
줄였거든요.
and runs through data generation rather than scientific discovery. Like the thing that is sort of powered, whether it's LLMs and agents, everything around robotics as well, and embodiment-free control, is scaling laws. And one of the things that we've established over the course of the last 24 months is scaling laws holding in this domain as well.
괜찮은 것 같아.
And that,
영상 조금만 더
I think that
줄여야겠다.
changes everything for industrials.
That's super exciting. I think something that is not intuitive to folks who work outside of the hard engineering domains is that actually it is a computationally bound field, right? Because I think of AI as being incredibly compute intensive, but it's actually much more efficient and much faster than some of the approaches that actually dominate today.
And it's worse than that. It's because you're generating simulations that can take multiple days.
이거
If I want to simulate
보려 그러면은
combustion inside a
빡
large
집중해서
jet
영어
engine,
리스닝 해야
it could be
돼가지고
500
이거 쉽지
hours
않은데?
plus. If I want to be able to now, understand what combustion looks like under, leaner conditions, 1% leaner conditions,
일단 마실
you can
것만 하나
blow that
넣겠습니다.
simulation time up by an order of magnitude, and it becomes completely intractable to design things when things are so compute intensive, whether they take so long. But what's worse is that there is no such thing really as reuse for numerical simulation data. And one of the things that's changing here is the generation of numerical simulation data to generate the training corpus that I need to be able to bring, to have AI models that understand physics and chemistry at the fidelity required for a lot of these applications. These things can be fine-tuned and steered into new domains and applications, but that paradigm shift of having a training corpus to train
일단
models
자막
is
CC가 안
something that's
되고요.
entirely different from what engineering sits on today.
Genuine curiosity question. Did your customers keep all of those simulation
무알콜
results
맥주를
in
가져왔어요.
reserve, and is it just about accessing them,
야밤이니까.
or did they throw them away?
The cost of storage being non-zero means that that data is systematically purged, yes.
Oh man, data being systematically purged. Deepak,
자,
some of the things that you've shown us at Skilled, where you can train a new robot that you've never trained on before and make it work and do things that it never was taught to do. Is it really, are robotics, is it generalizing? Are your models generalizing? Is it true that it's generalizing?
Yes.
스킬드
So at
창업자인
Skilled, we are
파탁한테
building a
물어보죠.
general purpose
진짜
brain for
제너럴라이즈 되는 거
robots,
맞냐고.
which means that any robot, any task, one brain. So as you mentioned, Alfred, this is absurdly general. Like just to put in words, like the
CEO니까
same brain
당연히 진짜
controlling a
제너럴하다고
humanoid
대답할
in a
수밖에
kitchen
없죠.
environment,
다들
the same
이제
brain controlling a
데모만
quadruped
봐서는
dog
믿지
going
못하는 것
around in
같아요.
busy areas, the same brain making a robotic arm cook an egg or omelette. Now, it is generalizing, and as you can see in the results we have released, you can put a new robot, you can either change the shape of the robot by removing limbs, it can adapt on the
아무
fly.
로봇 바꿔도 다
But
잘
the key question is
동작한다.
why? Like, why are we even going so general? Because it's so much beyond even humans. Even humans control only one body. And the reason for that is data. I very much agree.
데이터
In the previous
때문에
points
로봇이
that
바뀌어도 된다. 사람은 몸이 안
data is
바뀌는데
scarce. In language, vision, speech, we had the luxury of having lots of data and being able to just apply the wave of AI and all these models to the next field, next field, next field. But in robotics, data itself is a problem. And by having this brain so general,
근데
we
이제
can improve
스킬드를
it
팔로우업
with
하신
data
분들은
from
아마
any
느끼셨을
kind of
텐데
robot.
스킬드만
No matter,
뭔가
we don't differentiate. We don't
보여주는 게
distinguish.
다르다는 거
We are not partial. We can use data from a
느껴지시나요?
humanoid acting in a kitchen, even a quadruped going on a road, learning something, helps other robots do new things in the background. And that is the main thesis behind this approach.
And through your approach, are you able to explain how you can rip off a limb and it still adapts? Can you explain how that happens?
그렇죠.
Or is it
어댑팅이 어떻게
just
되는 건지
the models
설명해 줄
just
수
do it?
있나요? 그게 이제
So,
많이 다르거든요, 혼자.
The key difference in some ways is, so if you have heard the term in-context learning in language models, right? Now this
저
term in
인컨텍스트
itself
러닝이라고
is
하죠.
only about 3-4 years old. Like in the whole history of AI, you would never, and Raquel here has also been a professor, so she would say this term was not existent. We always were training models to be efficient at learning. But turned out, when we made these models learn at big scale, learning efficiently just emerged as a property. So you can learn by showing you a few examples. And that is what is happening here. So these
그렇죠. 이제 우리가 인간 관점에서 러닝이 두 가지가 있는데 인간은 그냥 알려주면 바로 하지만 이때까지는 모델을 튜닝해서 트레이닝해서 모델을 동작을 시켰는데 얘는 지금 인 컨텍스트 러닝이라고 하죠. 혼자 다르잖아요, 사실.
Motor to power goes in the context and it learns from that context. So this idea of in-context learning had only been shown in language or vision where there is ample data and not outside that field, not even outside language pretty much. This is the first time it is shown in the physical world and thanks to simulation and other approaches which you can leverage here.
Now, some of the models are, in the open source world, they figure out how to distill them pretty cheaply. It's pretty hard to distill a robotics model, from what I understand.
It is pretty hard to
디스틸레이션.
model
네,
first.
로봇 모델은
Obviously,
디스틸레이션
even
힘들다.
the pre-training models don't have as much data. So we are already solving that problem. Second, when you deploy a model on a robot, you over time want that model to become more specialized. And as we are also finding with language models, like if you are using a model for coding, you don't really care at the time how good is it in writing a prose, right? So, but the key is you cannot directly jump for that specialty. Like you have to first go general and then go specialized. Because if you directly go specialized, you will not have enough data and you'll overfit. And that's the
그래서
same
제너럴
philosophy.
모델을 만들고 그
So in
다음에
robotics,
스페셜한
we are
모델을
not
만들어야
really
된다
like,
이제는.
you don't have access to the whole original
Okay.
brain. You have
당연한
access to
소리.
a distilled version on the device. So it protects against that. But it's also challenging.
인 컨텍스트 러닝 더
because
자세하게
now you have to
설명 안
fit
해주네요.
everything on a device and run,
얘는 모델
really
학습
fast and fast.
어댑팅 하는 거를 그
Daniel, at Open
프롬프트에
Evidence, you
퓨전
guys
넣는
have made
것처럼
the
하거든요.
decision
모델을
to train your own
튜닝하는 게 아니라
models to,
그 얘기를
get
좀
to
해주면
specialized
좋겠는데.
models, and then you'll describe it as medical superintelligence. Why do that versus use the general models?
Well, we also use general models, but in medicine, we're talking about physical world intelligence. The
영상
ultimate
소리 더
feedback
띄워도
loop from the
괜찮아요?
physical
영상
world
소리 좀
that we
띄울게요,
care
그러면.
about as humans is the human body. And I think
너무
it's
큰
important to
말씀하세요.
distinguish the efforts in medical AI from some of the other efforts in AI. Efforts in coding, for example, are extremely valuable. We use it internally in the company. But if AI generates the wrong line of code, you can delete that, you could try it out, you could see that it's not working, and you can try something else. If AI generates the wrong treatment recommendation, you're going to get a feedback loop from the physical world, from the human body, that you're not so happy to just try again or delete because it's going to hurt a patient. Or
시작하기 전이니까 보이나?
at best, not
요즘
cure what
다음
you're trying to cure.
유행이라는 버터떡을 가져왔습니다.
Like many of my
버터떡 하나
colleagues on
조지고
the stage, you
시작하겠습니다.
have to go into the physical world. You have to understand what are the feedback loops that come from the human brain, which is what a neurologist does. What are the feedback loops that come from the human heart, which is what a cardiologist does. And medicine, more than other fields, doesn't need to be explained to what specialization is. In many other fields, this idea in AI of specialized intelligence, specialized agents, and so on, is newer, and it's less intuitive to the people working in the fields. In medicine, they've been specializing since medical school and then beyond. And so this is sort of running with the theme of this panel, which is why I'm on this panel and not on one of the other panels, which is you have to be grounded in the physical world. You have to be grounded in what the physical world dictates and allows. And in the physical world of medicine, in biophysical medicine and the human body, the brain and the heart and all of the other organs only allow so much. So then you have to recreate and mirror the type of specialization in knowledge work that the medical community has already self-organized around. And that's why as we train AI, it's, in our opinion, not going to look like one specialized general intelligence, but many sub-specialized sub-intelligences that collaborate and cooperate together. And each physician in this future is going to have the benefit of a digital twin of a cardiologist, a digital twin of a neurologist, a digital twin of every specialist and subspecialist that they can elastically and dynamically call up to help them on a patient.
이분은 누구죠?
Yeah,
어디서
it
많이
seems
본 것 같은데
obvious
저
why,
뒤에 자막이 안 떠가지고 누군지
consumers
모르겠네요.
should want trustworthy medical AI, but I think what you're describing is actually a model of medicine, that is, to me, idealized, which kind of actually looks like the way models work today, right? You have a router, you go to an expert model that is better at this particular task, higher performance. Maybe you can just restate why you think these, clinicians and doctors who did go to medical school and specialize need AI at all, right? They have a bunch of this knowledge themselves.
It's a great question. So I would actually argue that in the 1920s, when the tools of
오픈
medicine were
에비던스구나.
gauze and scissors, they probably didn't need AI. What's happened in the last 20 or 30 years is this golden age of biotechnology, where we've developed all these tools, these drugs, which are tools for physicians that extend their toolkit beyond the gauze and scissors that you might see in a World War I film. But there are too many of these tools now. If you speak to any physician, they'll say there's 10 to 20,000 FDA-approved drug compounds. They all interact in ways sometimes which are benign, but in other cases which are very harmful to the patient. The combinatorial of 10,000 or let alone 20,000 FDA-approved drug compounds is nearly infinite. Medical school as a vehicle, which is a 4-year program, doesn't allow any more physicians, human physicians, limited by the wet brains that we have in our skulls, to cover the enormous surface area of biomedical knowledge. So it's this sort of tension that, on the one hand, it's this phenomenal accomplishment of the human species that we've developed all these drugs, that there are 2 new biomedical papers being published every minute, 24 hours a day, that there's 40 million biomedical papers published in the world medical literature.
And it's only going to accelerate.
It's accelerating, it's doubling every 5 years, even by the most conservative
저
estimates.
메디컬
by
페이퍼가
liberal
너무
estimates, it's
1분마다
doubling
막
every 73 days.
조직에
No matter
나온다고
what it
다 알
is,
수가
even if
없다고.
it's every 5
네,
years,
맞는 말이죠.
they can't just stay in medical school. They can't, even if it were every 5 years, they'd have to just stay in medical school, which is a 4-year program for the rest of their life. That's not feasible. And even people went to medical school 20 or 30 years ago. They've all had this moment of studying 12 hours a day. They're tired.
그냥
It's
이제
the
맞는
end of the
말인 것
day, and
같아.
they wish they could
그러니까
just
우리가
have
이때까지 이
a
의사라는
twin.
시스템이
People
뭐
have
의사가
had
아니라
this thought long
전문직
before
다
Jensen was talking
마찬가지인데
about digital twins, which is why Jensen is so right. That the
이
future
수련
is digital
기간을
twins. I think we've
N년을
all had this
거치고 거기서 배운
thought in
다음에
grad
그걸 가지고
school, if I could just
남은
have a
평생을
bunch of twins
의료
of
행위를
me that could
하든
learn
뭐
this material,
변호사라고 치면
I
법적
could go to
행위를 하든 뭐 이런 것들을 하는
Yeah, what's
건데
grad school today?
뭐 박사, 엔지니어링
For
박사
those of
이런
you who
것도
remember what
비슷한
grad school
이치고
was,
근데 너무 빨리
we've all
바뀌니까
had that
그때
experience. I wish I could just
배웠던
have
거를
a copy of
나중에
me that could learn this material
내가 학생 때
and
배웠던
know it, so I
게
could sort of
남아있지가 않잖아요.
elastically call up
의료는
the next
이때까지
morning
막
when I have
그렇게까지
the
빨리
test.
바뀌진
Well, that's the
않았던 것
experience
같고
of
이제
physicians. The
앞으로는
next morning they have
엄청
the
빨리
test.
바뀔
The test is
텐데
the patient. It's a patient who exists in a body. The body
근데
exists
맨날
in the
맨날
physical world.
다시 의대를
You
갈
can't
수는
just delete
없으니까
the
의사들이
generated line of code that
이제
doesn't
세미나
work.
정도
The feedback
가는
loop
게 이제
might be
최선일
catastrophic.
텐데
So we need to
그래서
help
AI가 이제
physicians
필요하다 뭐
help
이런
patients by giving
이야기인
them
것 같죠?
digital twins that can help them learn all this material.
Can I follow up, Daniel, on one thing that you've done twice? You've done this twice. This is your second company in AI. This is AI for medicine. Your previous company was Kensho AI for finance. How are you building these two companies differently?
오픈 에비던스
Open
전에는
evidence
파이낸셜 AI를 했구나
Well,
저
one
사람은.
of the gentlemen on the stage here prior was with me at Kensho. So first of all, it's great to see all these Kensho alumni starting their own companies. Harrison
from
Lang Chain and Mikey Schulman at Suno and Martin, come on, all these guys. I think the world has changed so much that it would almost be easier to enumerate the overlap than to enumerate the differences. The overlap involves, there's still a venture capital landscape. You need capital. That kind of is the end of the overlap. Everything is so completely different today.
I've learned nothing.
I've really had to start from scratch all over again. The technology that exists that you can presuppose today as your starting level, I think you're going to, and this is maybe still I don't know if this is a heterodox statement or it's not, but I think you're going to have some of the most valuable companies in the world 10 or 15 years from now have sub 100 employees. And I think the world's not prepared for that. Take open evidence. We have sub 100 employees, and 300 million Americans this year are going to be treated by a doctor who used open evidence in the loop. So, we're talking about each employee indirectly supporting 6 million patients. I mean, the scale is unfathomable. That's directly a result of what Jensen and NVIDIA and these tools and the people who develop on top
제가
of
소리 밸런스를
that
맞추니까 좀 잘 안
technology have
들려가지고
enabled
헤드폰을
as
가져왔습니다.
the new starting point. And I think the world economy and certainly the tech economy is going to look unrecognizable. You're already seeing it in some of the companies on this stage and some of the companies that were on the previous stage, where you have some of the most impactful companies certainly some of the most impactful companies in the world have sub 2,000 people, sub 3,000 people. And some of the most impactful companies in the world, including Open Evidence, have sub 100 people supporting 300 million patient interactions with doctors in the United States alone. So that's a new tech economy, that's a new reality, and I've had to learn all that from scratch.
Raquel, you've been working on autonomy for a long time. What lesson is there from how long self-driving is taking and why you think this is the year of scale that we should take to other physical AI domains?
Yeah, and I think self-driving can, is ahead in many ways of some of the other physical AI, domains like humanoids, etc. So I think there is quite a bit to learn. One is that, self-driving started with a roboticist approach, which was, try to build a very overly complex software stack where you basically hand-code everything. And one of the reasons I started Wabi 5 years ago was because I didn't believe that was going to get us to a point where scale could ever happen, right? And with a mindset that we should rethink the world with an AI-first approach, right? With a simulation-first approach, which we, I think in this panel we all believe that that's the way where you can really, for physical AI and safety-critical applications, is the only way to really expose the system, test the system, to things that otherwise will have tremendous consequences, right? And one of the things that I think will be very important to take from self-driving is how we approach safety, right? Because, as in your domain, consequences of a mistake are actually tremendous, right? So safety cannot be an afterthought. So one of the things that we pioneer is in, can we build simulation systems and even simulation systems that work in the physical world as you drive, like mixed reality testing, augmented reality, where you can really prove for the first time the safety of self-driving systems at this scale. And this new way of doing end-to-end verifiable with reasoning, this way of testing with simulation first, really is going to bring
갑자기 이상한 소리가
robotics to
들리는데요.
the next level. And I think that you will see more and more companies in other physical AI applications really adopting that that type of technology.
Is physics
역시
physics X helping
엔비디아
us
행사답게
completely
엔드-투-엔드
shorten the
시뮬레이션 잘
development
되고
cycle
이제
of
그 스케일
things in
가능하다.
engineering
네, 이런
and
얘기였고.
taking into account all the safety measures that you need to take, because if a jet engine explodes, that would not be a good thing.
Yeah, so yes, it wouldn't be a good thing, right? So I think in a whole lot of industrial applications, you can't really tolerate hallucinations. Yeah. We want to be able to build models that can reason and predict physics at the fidelity required for a lot of the applications, whether it's designing things like a jet engine or it's designing a piece of semiconductor manufacturing equipment. But in designing something, we don't have the same, let's say, safety issues. Because what we can do is we can use the AI to be able to explore this huge combinatorial space. We can deploy a whole lot more algorithmic sophistication to how we do that. Now that the simulation step is incredibly fast, but we can then go back to our certified numerical tools in order to be able to validate that we got things right. We can go to a wind tunnel or an engine dyno or the wet lab to be able to validate that things work well. But that's only on the design side. Like the moment that you go into operational control, like deploying AI into a smelter, on a mining site to do copper heap leaching, on a vehicle that is going to do active cooling for the battery itself, or on a piece of semiconductor manufacturing equipment deployed into a fab. In all of those situations, you want to make sure that you understand what the uncertainties are going to be. And there it's a question of having sort of safety guardrails. There are ways to be able to do that. I think that the thing that's incredibly exciting is that we're getting into a paradigm where the same AI that is being used to design the thing is being used across the whole product development lifecycle. So on the manufacturing side, in control applications, and that's different and exciting.
Deepak, everybody wants to know if you look forward, is it next year? Is it the year after? Is it 2030? This is like unimaginable timelines by AI standards. Like when do we actually see robots with more general capability and which applications first?
So I think
언제
robotics
로봇이
is the
진짜
longest
실제로
existing field
들어오냐.
of AI and the last one to arrive, right? And there is a reason for it, because it is not like ChatGPT or where you can just build a completely intelligent agent and then have access to millions of people on the first week or day one, right? Here, physical rollout takes time. Physical AI is the biggest market, right? Now, the question is which area? Because will I have a robot in my home this year cooking food for me, cleaning? I mean, that's what sure look like from if you look at the internet. But it would be very weird if you have a humanoid robot in your home this year, which can do all the cooking, all the work for you, and you still don't see robots around you in factories, grocery store, hospitals, and everything else is just done by manual. Even though the numbers say otherwise, there are already million more jobs available than people are able to fill them. So there is a huge demand. In my opinion, the answer is from today all the way to 2030, like whatever year you put in. But the area of application will differ. So today, I cannot reveal details, but we have a big announcement coming that we are
big announcement
going
coming.
to do big deployments in enterprise in one shot, by partnering with the key players. This is where you start. Enterprise, because over there you
엔터프라이즈에서부터
actually
오늘 시작할
have
거라고요.
people who would pay for robot will not sue you if something goes wrong. And you can use that data to go to a bit more unstructured. let's say hospitals, grocery stores, and then you use that data to go even more unstructured, like homes. You
팩토리,
solve problems
그다음에
where you
병원,
increase
그다음에 가정.
complexity of the generality over time,
점점 더
and you
복잡한
use the
데로 나갈
data from the
거다.
previous iteration for the next iteration. This is what we call a data flywheel. Now, data flywheel is the reason self-driving is even possible today. Our goal is to establish data flywheel step by step.
뭐 데이터
and
플라이휠
not
역시
just jump to
얘기하죠.
the last thing.
로봇이 나가서
And
돌면서
you
데이터
will-
수집해야
some people
된다.
will get robots in homes, but the mass adoption will happen when you begin seeing robots around you everywhere else in unstructured areas.
Sounds like a really fun future. Thank you guys for taking AI to the physical world. I can't wait for all of the problems to be solved in the physical world.
Jensen's keynote is coming right up. For those of you who are still
네,
hanging
이제
out with
시작합니다.
us in Arena Green,
드디어
all are
젠슨
welcome
황
to join us
선생님.
inside, so make your way into the keynote now.
Tiffany has been out and about meeting with some of our guests. Tiffany, how's it going out there?
It's going great. Thanks, Alfred. I am here with Alex Kendall, who is the co-founder and CEO of Wave. Alex, autonomous driving is really on everyone's minds. It's the buzz around here, which is so exciting. I think another thing that coincides with that is around the safety when it comes to AI and operating in the real world. How do you think about that?
Well, isn't it fantastic to see the automotive industry really galvanizing around end-to-end AI for autonomous driving? When we pioneered this work a decade ago, this was quite a contrarian idea. But what we've seen is recently there's so many
가슴털이 장난
demos now
아니시네요.
possible showing that this can actually become a feasible product. But we had a demo 5 years ago, and what we've spent the last 5 years is showing how this can be a product at global automotive scale. So we've now done zero-shot testing in over 500 cities through Europe, Asia, North America, and we've shown how we can build a world model that can really understand the risk and anticipate the busy dynamics of the roads that we live in. So this means that we're now in a position to not just show demos, but bring embodied AI into consumer products and robotaxis at a truly world scale.
Absolutely. And you mentioned
주행
you look
진짜
back, you know,
시작된다.
5 years to where you are
그런
today. It's
얘기였던 것
incredible
같고.
the speed which you are moving. I want to look ahead a little bit. What does the next decade look like as AI enters the physical world?
Oh, look, every vehicle is going to be autonomous in the future, and I think automotive is going to be the first large-scale demonstration of embodied AI. But of course, it's just the beginning. But we're really excited to see some major steps forward this year. Of course, we're partnering with great companies like Uber, Stellantis, Mercedes, and of course, Nissan, where this week we're unveiling a new robotaxi. It's on here display at
닛산에서
GTC.
로보택시
We
새거
announced that we're
나온다고요?
gonna be launching it and
여기
bringing it
GTC에서
into
부스에
trials in
있나
over 10
보네요.
cities around the world with Uber. So we're really excited to launch that and see our AI come into consumer vehicles and robotaxis at scale very soon.
That is so exciting. And you mentioned it's on display this week.
Yeah, come take a ride. I took a ride as a lot of guests here at the event this week, where they can ride in our robotaxi and
로보택시
consumer
진짜 다
vehicles,
태워주나 봐요, 저희 가면.
experience autonomy. It's really designed to be natural, human-like. So it drives with the hardware that's already built into millions of vehicles today. So no bespoke hardware or retrofit. It can work with the existing vehicle's hardware that's being produced at millions of scale volume and doesn't need a high definition map. So it doesn't need to drive in a pre-mapped area, but can truly drive at a global scale. We're the only company now to drive zero shot in over 500 cities. And we've seen this system drive all around the world. It's quite remarkable. Please go have a drive.
I definitely am going to need to do that. That's incredible. And you said repeat that again, that stat at the end you said. You're the only company, finish that sentence,
To have driven zero shot. I mean, AI driving and safety is all about the
지금
ability to
지로샷,
generalize.
처음 보는
And driving
곳에서
zero
달릴 수
shot
있는
means
유일한
driving
회사라고
somewhere
주장을 하고
where
있나
you've
봐요.
never had training data from that location before. And this is really important because the world's too large to collect data from every single experience. So you need to be able to learn general purpose behaviors, and that's exactly what we've developed with our world model. The ability to anticipate risk,
월드 모델로
understand
그런 걸
the
달성을
dynamic
했다.
and
그렇게 얘기를
unexpected
하네요.
movement of people all around the world. And to take this behavior and generalize it to new scenes, to new vehicles, to new countries, cities, weather, that's the core problem of embodied AI and what we've been able to show.
Wow, that's truly incredible. I am so excited for this ride. You will definitely see me taking one. Alex, thank you so much for your time.
Awesome, thank you.
So we have covered a lot today, a lot of different technologies from agentic AI, physical AI. I mean, we even spoke about energy and everything in between. It is truly an exciting time. Now, if you're not in your seat already, you better get there quickly because the keynote is about to start. Thank you so much for following along today, joining these conversations with me. I mean, I don't know about you, but they were so inspiring, so much fun. Now, before we go, I'm going to throw it back to the stage.
Thanks, Tiff. Great work out there.
So that's a wrap for the pregame.
In just moments, NVIDIA CEO Jensen Huang will take the stage with his vision for how NVIDIA is building the future we've been all talking about on the stage.
네, 이제
We'd like
시작하네요.
to thank our many incredible guests, top AI leaders who are bringing about the next industrial revolution. I also want to thank my co-hosts, Gavin Baker and Alfred Lin, Tiffany Jansen, and the entire NVIDIA team for an unforgettable morning of insights and inspiring ideas.
Thank you, Sarah. Our day's not done yet. Hopefully, they save some seats for us because we're going to have to run over there for Jensen's keynote. I wouldn't want to miss it.
Me neither. From the SAP Center in San Jose, California, thanks for watching.
Bye.
왜 이렇게 뭔가 아저씨 어색하신 것 같죠? 근데 이렇게 키노트 앞에 사전 쇼도 열심히 하는지 몰랐네요. 키노트 다른 영상에서 해요? 그런가 보네. 엔비디아 채널로 가자. 아, 그러네요. 키노트는 영상 따로 있구나. 아유, 감사합니다. 시작하고 나서 부랴부랴 틀 뻔했네. 17분 전. 영상 소리가 조금 큰 것 같아. 소리가 좀 안 맞으면 말씀해 주세요. 부탁드릴게요. 아니, 이렇게 사전 쇼도 파텍이랑 막 이렇게 유명한 사람들 피직스 X랑 다 불러가지고 하는지 처음 알았네요. 맨날 키노트만 요약으로 보다 보니까. 문 열어. 빨리 문 열어.
Woke up feeling something shift. Same room but the air felt thick. Mirror said I'm still that kid. I said you're bigger than this. Tie my laces, hands still shook. First step was the hardest one. Every lap, every sideways look, all fade when the race is run. I carried every doubt lightweight. Now
그러게 오늘 뭘 발표할 거야?
You can write it on the page. Everything changed. A legend was made today. From every little scar, every heartbreak, took all of the nights I almost walked away. And I turned them into gold in the name.
스파크 2 이런 거 나오지 않겠지?
Up when I crossed that line, flashbulbs in my open eyes, but the loudest thing I heard was my own voice saying rise. All the times I came up short, played them back like old home tapes. Now they're just the proof I've grown. this day. I carried
3시 됐습니다.
now I'm lighter than the flame. You can write it on the page. Everything changed. A legend was made today. From every little scar, every heartbreak. Took all of the nights I almost walked away, and I turned them into gold, into my name. Remember this space, this place. When the crowd stands up and they all say, a legend was made today. A
이거
legend was
먹겠죠?
made today. This is for the kid who writes, for the one who's tired of trying. If you're standing on that edge, let this moment be your sign. A legend was
이거를
made
엔비디아 공식 라이브를 19,000명이나 보고 있네.
A legend was made today. From every little scar, every heartbreak. Took all of the nights I almost walked away, and I turned them into gold in my name. Remember this space, this place. When the crowd stands up and they all say, a legend was made today. A legend was made today. A legend was made today.
왜 시작 안 해요?
Yeah,
하나?
you feel that? Alright.
아니네. 다음 노래네.
Go ahead, let it ride, let it go where you are. You just keep getting better, just keep getting better. You's a bona fide superstar. You just keep getting better, just keep getting better.
So, hey, say a few things. Everybody looking for a new thing. There you go, moonwalking like two wings. Just flew in, put the room in the mood ring. You got people talking your name up. I don't know how you came up, but either way you go, you deserve it. You put the work in, it's so perfect. Cause someone gets, but wait. You get what you want when you say. You can have the world if you want on a plate. Whoever said you ain't who you are, their mistake. It's up cause you are, you don't hear 'em, no way. Don't walk, you levitate. You see your chance, don't hesitate. Got look too good on your resume when that record play, yeah.
Go ahead, let it ride, let it go where you are. You just keep getting better, just keep getting better. You's a bona fide superstar. You just keep getting better, just keep getting better. Baby, don't you slow it down. Not for no one, baby, not for no one.
아니 왜 시작 안 해요 이거? 불안하게. 23,000명. 이거 맞잖아요, 그죠?
Night living life for the plot line. With good melody, I got a top line. You number one, make 'em settle for the top line. Cause you always in the bag, pop another tag. Quality is everything, cause moments never last. I don't wanna know how many minutes do we have till it's midnight. High heels click like glass on the floor. I heard people don't dance anymore. Never got the memo when it came, you ignore. People staring at you like they never seen a real one round these parts before. But you don't walk, you levitate. You see your chance, don't hesitate. Gotta look too good on your resume when that record play, yeah. We
Go ahead, let it ride, let it go where you are. You just keep getting better, just keep getting better. You's a bona fide superstar. You just keep getting better, just keep getting better. Baby, don't you slow it down. Not for no one, baby, not for no one, baby, no. Go ahead, let it ride, let it go where you are. You just keep getting better. Don't you ever let up, oh no.
근데 이거 노래 다 진짜 노래예요? 아는 노래 있으세요? 다 생성된 노래이려나?
False wrinkle on my face, coffee stain on my plain white shirt. Same old drink, same tie, playlist thinking, is this
여기 엔비디아 공식 채널은 채팅 없나?
worth? Getting in the lights up my screen,
채팅 없네.
sent the text that flips my way. Keep your eyes wide open. Now
링크드인 엔비디아 컴퍼니 웹사이트 이런 거밖에 없네.
after weeks of play,
언제 시작해? 어차피 노래만 나오니까 왠지 현장에 문제가 있는 것 같아. 잠시 다른 걸 한번 봐볼까? 그러면 엔비디아 채널에 뭐가 올라왔을까요? 아니네, 3일 전 거까지밖에 없네. 키노트 티저 하나 보고 올까요? 잠깐 소리를 끄고 티저를 보러 갔다 오죠. 30초짜리.
We're reinventing AI across everything from chips to infrastructure to models to applications. And our job is to create the entire stack so that all of you could create incredible applications for the rest of the world.
뭐 별거 없네. 이거밖에 없네. 라이브. 돌아가죠. 5 days ago.
Well, this is incredible. We're sitting outside Bucks in Woodside. So we're going to San Francisco today.
That's right.
I was going to say, let me know when you're in autonomous mode, then I could be less concerned about my safety. We have the only stack in the world that has a end-to-end
That's right.
AV stack.
That's right.
As well as a traceable, human-engineered
That's
AV
right.
stack.
That's right. Which is very critical because, for end-to-end model, it's very difficult to verify. Basically, it's always safe, right?
That's right.
And the classical stack is developed based on the, as a protocol and a process. We know how to ensure safety software.
Yeah, the thing that's a miracle about Alpamayo is that it does amazing things.
Yeah.
And it drives like a human.
That's right.
Because it's
벤치
end-to-end,
알파마요
whenever there
태운 거 하고 있나
are
봐요.
things that needs to be improved, you know that you can
손은 그래도 열심히 올려놓고 있죠.
through the whole model, and you'll improve it for sure.
Yeah.
I think the challenge, of course, is Alpamayo is as incredibly smart as it is, and it can reason about the circumstance. We don't know what it can't do.
That's right. Yeah.
And so that's the challenge, and that's the reason why our classical stack is so incredibly important.
That's right.
The thing that's really great about Alpamayo and our stack is that I don't ever feel that Alpamayo would ever be allowed to do something that is out of distribution. And the reason for that is because our classical stack gets involved and prevents it from happening.
Right.
근데 여러분들 아까 보니까 닛산 로보택시도 나온다고 하던데 로보택시 있으면 탈 것 같으세요?
We have iterated right now the version is I think 2300. We labeled based on the number of iteration we have essentially, and roughly speaking, we have this is a roughly over a year, right? So we have in average like 7 models being iterated every day. Obviously, not every single one of them make to the car. But because this process is, just imaging and trajectory out, there's the manual steps in between in the development process are just minimal. That's why we can iterate super fast.
Well, the thing that's really great about end-to-end models is that whenever you're improving the model, because it's one giant model that's end-to-end.
That's right.
You're not going to fix one thing and break something else. The classical models, because there's so many different modules, you fix this one thing.
The logic sometimes contradicts with each other.
That's right.
Yeah.
And so it's so brittle, and you fix one thing, you're chasing cats and dogs around the table, and it's really hard. Most control systems, which are built the classical way, have the same problem.
옛날처럼
has so
모듈러 되어
many,
있는 게 오히려 하나
steps.
고치면 다른 게
For
다 망가질
example,
수도
right, today
있어서
we actually gonna
더
see
안
speed bump,
바꾸기가
based on
힘들다
Mario.
이런 이야기를 하는 것 같아요.
If you think about how do you detect speed bump and react to it properly, you have to break into many steps. Start from perception, and it have to be added in the word model in the context fusion, and then basically you have to decide how early you have to slow down by how much. And maybe even based on different speed bump, you have to do things differently. But with the end-to-end model, you just basically just happens. Actually, we didn't even plan for it; it just happened.
Yeah, right.
So it's pretty amazing.
There's so many
엔드투엔드
people
모델이
building end-to-end
그냥
models.
왜 그런지도
But I
모르고
really
알아서
think that
잘한다
it's
이런
the
게 이제
fusion of the
옛날에는
two.
되게
Yes.
That's
공격받는
revolutionary. That
요소였는데
gives you
Yeah.
the superhuman
그래서
well,
이제
the
잘못할
amazing
수도 있는 거
driving
아니냐.
capability.
And the
그런데
safety.
이제는
And the
그냥
safety.
That's right. Back to the model, actually,
칭찬처럼
it does
얘기를 하네요.
that because it's so big, right? Actually, we do see sometimes, when you try to address something, it have some, something else might get regressed.
Right.
So being able to establish a basically full-blown, very comprehensive, basically closed-loop evaluation, what we call CLE, is super critical. This is how we gate our model to make sure sort of the bad babies
Yeah.
get filtered out.
The thing that I still love though, and I think this proves to be true, that even when you have a regression on Alpamayo, your classical stack would always guardrail it.
That's right. Actually, that's why basically, our
네,
development
그래서
speed has
엔드투엔드
been
모델이
so
어쨌든
good
이상한 짓 할 수도
because
있으니까
you always have a backup, essentially.
That's right.
백업은
Even
무조건
if it
있다.
has minor hiccups,
That's
it's okay.
right.
We will keep reiterating and
That's right.
just keep getting better.
You never have a loss of safety. You have a loss of
That's right.
capability, but not a loss of safety.
Yeah.
This is going to be so critical for a robo-taxi when that happens. You know what I'm saying?
That's right. That is the advantage we have as well as we move into L3 and L4, because we have redundant stack even L2++ to scale it basically for L3 and L4. It's just so natural.
That's right. Yeah, that's critical. And then there'll be the teleoperations,
Yeah.
right, as a backup system. And then, every
For
robo-taxi,
robotaxi, yes.
every robo-taxi service should have, a air traffic control center. And the thing that's really great with our technology is that, for whatever reason, if the robo-taxi were to get stuck, all you have to do is give it a couple of waypoints, the human injected waypoint,
That's
and
right.
it should be able to navigate itself right out of it.
저거 따라가면서 찍는 카메라는
And
뭘까요?
because it has a
뒤에 그냥
has a
차가
safety
따라가는
stack,
거겠지.
a backup stack, no safety would ever be jeopardized.
That's right.
키노트 안 해요. 키노트 제가 지금 보고 있는데
capabilities.
또 시작을 안 해요.
Because the classical, when we do lane change, we have to select
뭐야?
gap. We have to do a
그렇죠.
lot of basically
그것도
rules
시작을
and
안 해.
heuristics, essentially,
Right.
to make sure it's safe. So sometimes it's a bit timid, essentially, when you have, cars in the front, you have cars in the back. Basically, the lane
There's so
change.
many
제가
rules.
일단
That's
저는
right.
지금
Yeah.
이 책상에다 띄워놓고
And,
모니터링 하고
Mario
있거든요.
basically in the
화면
city,
뜨면은 바로
it's
옮겨가려고.
just doing an amazing job in the lane change. It's also very human-like,
리조트
essentially,
왜
and
시작 안
never
해?
give you the feeling of rigidness.
Well, it imitates the human from all the drives that it's been on,
Yeah.
and then it generalizes from that.
That's right. Yeah.
The basic concept of deep learning to essentially
혹시 지금
memorize
오시는
and
분들 헷갈리실
generalize
수도 있으니까 제가 채팅에다가 써놔야겠다.
works just fine for a self-driving car. Works.
AI is the single most important technology to make self-driving possible, essentially, right?
Yeah.
But I have been working on this, obviously, as you know, for a long time. But the last 2-3 years, my God,
Yeah.
just it's iterating so fast.
Yeah.
If you think about
particularly
Uh-huh.
the using an end-to-end model
that's right. Yeah.
was a big deal.
Yeah, Gen AI basically. To some extent, you can think that the whole industry iterate on the first architecture, which is ML-based perception only, right, for 10 years.
Yeah.
And we made lots of progress. Robotaxi
야,
can be done that
딥러닝
way.
기반
Yeah.
비전 하는 거를 그냥 ML 베이스
But,
퍼셉션이라고
over the
하네.
last 3 years, we're iterating on, we first bring end-to-end model. Now we're adding reasoning to it.
뭐
It's really
한다.
2 generations in 3 years.
한다
The
한다.
two fundamental technologies that
Scan here for live caption. 시작해요. 라이브 캡션 뭐 하라고?
This is how intelligence is made. A new kind of factory. Generator of tokens. The building blocks of AI. Tokens have opened a new frontier, turning data into knowledge and drawing on all we have learned. Tokens are harnessing a new wave of clean energy. And unlocking the secrets of the stars. In virtual worlds, they help robots learn. And in the physical world, perfect. Forging new paths.
헐, 디든 로보틱스다.
And clearing the way
헐.
for harvest. In the moments that matter, tokens are already there. And in the miles between, they never stop. They work where human hands cannot. So we may all breathe easier. And the smallest hearts beat stronger. Tokens are helping us break new ground. On a scale never attempted to empower the world. So we can reach
Star Cloud 1, separation confirmed.
well beyond it. Together, we take the next great leap into a bright new future built for all mankind. And here is where it all begins.
Welcome to the stage, NVIDIA founder and CEO, Jensen Huang.
Welcome to GTC!
예, 웰컴.
I just want to remind you this is a tech conference. All these people lining up so early in the morning, all of you in here, it's great to see you. GTC. GTC, we're going to talk about technology. We're going to talk about platforms. NVIDIA has 3 platforms. You think that we mostly talk about one of them. It's related to CUDA-X. Our systems is another platform. And now we have a new platform called AI Factories. We're going to talk about all of them. And most importantly, we're going to talk about ecosystems. But before I start,
AI 팩토리라고 하네요.
let me thank our pre-game show hosts. I thought they did a great job. Sarah Go of Conviction. Alfred Lim, Sequoia Capital. NVIDIA's first venture capitalist, Gavin Baker, NVIDIA's first major institutional investor. These three people are deep in technology, deep in what's going on, and of course, they have
저분들 다
just a
VC
really broad reach of
사람들인데
technology ecosystem.
호스트
And
대비라고
of
하네요.
course, all of the VIPs that I hand-selected to join us today, all-star team. I want to thank all of you for that.
헐, 아까 해리슨 체이스도 나왔나 보다.
I also want to thank all the companies that are here. NVIDIA, as you know, is a platform company. We have technology, we have our platforms, we have rich ecosystem. And today, there are probably 100% of the $100 trillion of industry here. 450 companies sponsored this event. I want to thank you. 1,000 technical sessions, 2,000 speakers. This conference is going to cover every single layer of the 5-layer cake of artificial intelligence, from land, power, and shell, the infrastructure, to chips, to the platforms, the models, and of course, the most important, and ultimately, what's going to get this industry taken off is all of the applications. What it all began here. This is the 20th anniversary of CUDA.
오,
We've
쿠다
been working on
20년.
CUDA for 20 years. For 20 years, we've been dedicated to this architecture, this revolutionary invention, SIMT, single instruction, multi-threaded, writing scalar code could spawn off into multi-threaded application, much, much easier to program than SIMD. We recently added tiles so that we could help people program tensor cores and the structures of
심T로
mathematics
프로그램하는
that are
것보다
so
심T로
foundational
하는
to
게
artificial
좋다. 이제
intelligence
쿠다의
today.
주장이죠. 자기네들은 심T라고.
Thousands of tools and compilers and frameworks and libraries. In open source, there's a couple of 100,000 public projects. CUDA literally is integrated into every single ecosystem. This chart basically describes 100% of NVIDIA's strategies. You've been watching me talk about this slide from the very beginning. And ultimately, the single hardest thing to achieve is the thing on the bottom, installed base. It has taken us 20 years to now have built up hundreds of millions of GPUs and computing systems around the world that run CUDA. We are in every cloud. We're in every computer company. We serve just about every single industry. The installed base of CUDA is the reason why the flywheel is accelerating.
쿠다가 이제 다 깔려 있다는 걸 인스톨드 베이스라고 하네요. 진짜 대단한 것 같아요. 이제 진짜 저 생태계 이코시스템 GPU가 쭉 다 깔려 있음. 모든 소프트웨어가 다 저기서 만들어져 있음. 이런 것 때문에 엔비디아 벗어나기가 힘드니까 진짜 선구자 하면서 잘했던 것 같아요.
This flywheel is now accelerating. The number of downloads of NVIDIA libraries is incredibly accelerating. It's at a very large scale and growing faster than ever. This flywheel is what makes this computing platform able to sustain so much applications, so many new breakthroughs, but most importantly, it also enables these infrastructures to have extraordinarily useful life. And the reason for that is very obvious. There's so many applications that you can run on NVIDIA CUDA. We support every single phase of the AI lifecycle. We address every single data processing platform. We accelerate scientific principled solvers of all different kinds. And so the application reach is so great that once you install NVIDIA GPUs, the useful life of it is incredibly high. It is also one of the reasons why Ampere, that we shipped them some 6 years ago, the pricing of Ampere in the cloud is going up. And so all of that is made possible fundamentally because the install base is high, the flywheel is high, the developer reach is great. And when all of that happens, and we continuously update our software, the computing cost declines. The combination of accelerated computing speeding up applications tremendously. Meanwhile, as we continue to nurture and continue to update software over its life, not only do you get the first time pop, you get the continuous cost reduction.
컴퓨테이션이 점점 싸지고 있다. 네, 확실히 일단 GTC라서 시작은 쿠다 자랑부터 하고 시작하네요. 한국 새벽이죠. 네, 새벽이죠.
If we release a new optimization, it benefits millions. This applies to everybody in the world. This combination of dynamics is what makes the NVIDIA architecture expand its reach, accelerating its growth, at the same time driving down computing cost, which ultimately encourages new growth. So CUDA is at the center of it. But our journey to CUDA actually started 25 years ago. GeForce
1080. 저 대학원생 때 전 GPU 전공을 했었는데 그때 580으로 했었는데.
GeForce is NVIDIA's greatest marketing campaign. We attract future customers starting long before you could afford to pay for it yourself. Your parents paid. Your parents paid. Your parents paid for you to be NVIDIA customers. And every single year, they paid up year after year after year
부모님이
until
사준다고요?
someday you became an amazing computer scientist and became a proper customer, a proper developer. But this is the house that GeForce made. 25 years ago, we started our journey, which led to CUDA. 25 years ago, we invented the programmable shader. A perfectly
쿠다 나오기 전에 프로그래머블 쉐이더부터
unobvious
있었죠.
invention to make an accelerator programmable. The world's first programmable accelerator, the pixel shader. 25 years ago, that led us to explore
그래픽 카드 게임용 GPU가 진짜 GPU던 시절 얘기를 갑자기 하네요.
investments that we made, and we couldn't afford it at the time, and it consumed the vast majority of our company's profits, was to take CUDA on the backs of GeForce to every single computer. We dedicated ourselves to create this platform because we felt so strongly about its potential, but ultimately, the company's dedication to it, despite the hardships in the beginning, believing in every single day for 13 generations of 20 years, we now have CUDA installed everywhere. The pixel shader led to, of course, the revolution of GeForce. And then 10 years ago, we introduced, about 10 years ago, what is it, 8 years ago? We introduced RTX, a complete redesign of our architecture for the
GTX
modern
아니고
era of
이제
computer
RTX죠.
graphics. GeForce brought CUDA to the world. GeForce, therefore, enabled Alex Kruszewski and Ilya Sutskever and Jeff Hinton, Andrew Ng, and so many others to discover that the GPU could be their friend.
쿠다가 있어서 딥러닝이 나올 수 있었다. 갑자기 알렉스넷 역사 강의를 갑자기 하시대요. 맞는 말이긴 합니다.
That we would fuse programmable shading and introduce two new ideas. Ray tracing, hardware ray tracing, which is incredibly hard
진짜
to do.
오랜만에 듣네.
And the
알렉스.
new idea at the time, imagine
알렉스는
about
지금
10
뭘
years
하고
ago,
계실까요?
we thought that AI would revolutionize computer graphics. Just as GeForce brought AI to the world, AI is now going to go back and revolutionize how computer graphics is done all together. Well, today I'm going to show you something of the future. This is our next generation of graphics technology. We call it neural rendering, the fusion of 3D graphics and artificial intelligence. This is DLSS5. Take a look at it.
게임 이제 렌더링 다르게 하겠다고? 합치겠다고요? 아, DLSS5. 아. 3D 렌더링 하고 거기다가 한 번 더. 이야, 이렇게 보니까 진짜 쩔긴 하네. 그래 저게 이제 원래 하던 게임에서 하던 렌더링 가지고는 저런 머리카락 저런 게 절대 안 되거든요. 머리카락 흩날리는 것도 혹시 보여줄 수 있으면 보여주면 좋겠다. 그건 안 되겠지 아직. 저 수염 머리카락 이런 게 렌더링 엄청 많이 해야 되는 거하고 절대 안 되는 건데 렌더링 하고 디테일만 위에다 얹히는 거 좋은 것 같아요. 옷 흔들리고 하네 저런 거.
Computer graphics comes to life. Now, what did we do? We fused controllable 3D graphics, the ground truth of virtual worlds, the structured data. Remember this word, the structured data of virtual worlds, of generated worlds. We combined 3D graphics, structured data, with generative AI, probabilistic computing. One of them is completely predictive, the other one probabilistic, yet highly
근데
realistic.
저거 세레모니 하고 있는 거 드록바예요?
Combine these two ideas, control through structured data, controlled perfectly, and yet generating at the same time. And as a result, the content is beautiful, amazing, as well as controllable. This concept of fusing structured information and generative AI will repeat itself in one industry after another industry after another industry. Structured data is the foundation of trustworthy AI. Well, this is going to scare you a little bit. I'm going to flip the slide, and don't gasp. So we're going to go through this schematic for the rest of the time. This is my best slide. Every time I ask the team, what's my best slide? Repeatedly, this was it. They say, don't do it, Jensen. Don't do it. I said, no. These seats are free for some of you. So this is your price of admission. So this is structured data.
갑자기 농담 좀 섞어주고 공짜로 왔으니까 그냥 보라고.
Pandas, Velox, some of these really important, very large platforms, Snowflake, Databricks, EMR, Amazon EMR, Azure Fabric, Google Cloud, BigQuery. All of these platforms are processing data frames. These data frames are giant spreadsheets, and they hold all of life's information. This is the structured data, the ground truth of business. This is the ground truth of enterprise computing. Well, now we're going to have AI use structured data, and we better accelerate the living daylights out of it. It used to be okay, and we would, of course, we would accelerate structured data so that we could do more, we could do it more cheaply, we could do it more frequently per day, and keep the company running at a much more synchronized way. However, in the future, what's going to happen is these data structures are going to be used by AI, and AI is going to be much faster than us. Future agents are going to use structured databases as well. And then, of course, the unstructured database, the generative database. This database represents the vast majority of the world. Vector databases, unstructured data, PDFs, videos, speeches, all of the world's information, about 90% of what's generated every single year is unstructured data. Until now, this data has been completely useless to the world. We read it, we put it into our file
그 vs
system,
벡터 서치일까요?
Unfortunately, we can't query it. We can't search for it. It's hard to do that. And the reason for that is because there's no easy indexing of unstructured data. You have to understand its meaning, its purpose. And so now we have AI do that. Just as AI was able to solve multi-modality perception and understanding, you can use that same technology, multi-modality perception and understanding, to go read a PDF, to understand its meaning. And from that meaning, embed it into a larger structure that we can search into, we can query into. NVIDIA created two foundational libraries, just like we created RTX for 3D graphics. We created cuDF for data frames, structured data. We created cuVS for vector stores.
벡터 스토어구나.
Semantic data.
오케이. 멀티모달 임베딩 해가지고 PDF 같은 거 그 데이터 프레임 아까 거는 그냥 옛날처럼 표처럼 키밸류 이렇게 이쁘게 매칭되어 있는 거 하는 거 그냥 GPU로 찾겠다는 거고 그쵸. 컴플리케이트한 거 PDF 같은 거 멀티모달 임베딩으로 다 의미 해석해서 벡터로 스토어 해놓으면 세만틱 서치 할 수 있다 뭐 그런 얘기겠죠. 안 그래도 지난주에 제미나이 임베딩 2 나왔던데 멀티모달 임베딩 네이티블리 멀티모달 임베딩 나왔던데
We're announcing several of them. IBM, the inventor of SQL, one of the most important domain-specific languages of all time, is accelerating Watson X data with cuDF. Let's take a look at it.
60 years ago,
갑자기.
IBM introduced the System 360, the first modern platform for general-purpose computing, launching the computing era. Then SQL, a declarative language to query data without requiring the computer to be instructed step by step. And the data warehouse, each the foundations of modern enterprise computing. Today, IBM and NVIDIA are reinventing data processing for the era of AI by accelerating IBM Watson X data SQL engines with NVIDIA GPU computing libraries. Data is the ground truth that gives AI context and meaning. AI needs rapid access to massive data sets. Today's CPU data processing systems can't keep up. Nestle makes thousands of supply chain decisions every day. Their order-to-cash data mart aggregates every supply, order, and delivery event across global operations in 185 countries. On CPUs, Nestle refreshed the data mart a few times a day. With accelerated Watson X data running on NVIDIA GPUs, Nestle can run the same workload 5 times faster at 83% lower cost. The next computing platform has arrived, accelerated computing for the era of AI.
이렇게 SQL 쿠다 써가지고 cuDF라는 거 이용해서 더 빨리빨리 하겠다.
Processing in the cloud. We also accelerate data processing on-prem. As you know, Dell is the world-leading computer systems maker,
이번엔
and
델도 나오네.
they also are one of the world's leading storage providers. And they worked with us to create the Dell AI data platform that integrates cuDF and cuVS to create an accelerated data platform.
아까 IBM은 cuVS 없었죠? 벡터스토어 없었죠? 데이터 프레임만 가지고 SQL 잘 하는 것만 한 거죠.
This is cloud, Google Cloud, and Google Cloud, as you know, we've been working with Google Cloud for a very long time. We accelerate Google's Vertex AI. We now accelerate BigQuery, really important framework and really important platform. And this is an example of our work together with Snapchat, where we reduced their cost of computing by nearly 80%. When you accelerate data processing, when you accelerate computing, you get the benefit of speed, you get the benefit of scale, but most importantly, you also get the benefit of cost. And so all of those come together as one. It was originally called Moore's Law. Moore's Law was about getting performance doubling every couple of years. It's another way of saying, so long as the price remains about the same, and most computers remained about the same, you're also getting twice the performance every year, or you're reducing the cost of computing every single year. Well, Moore's Law has run out of steam. We need a new approach. Accelerated computing allows us to take these giant leaps forward. And as you will see later, because we continue to optimize the algorithms, and NVIDIA is an algorithm company, as we continue to optimize the algorithms, and because our reach
엔비디아
is so
갑자기
large,
알고리즘
our install
컴퍼니라고
base is so large,
열심히
we can
주장하고
reduce the
있습니다.
computing cost, increasing the scale, increasing the speed for everybody continuously. This is Google Cloud. You could see this pattern I just mentioned. I just wanted to show you 3 versions of it. NVIDIA built the accelerated computing platform. Has a bunch of libraries on top. I gave you 3 examples. RTX is one of them, cuDF is another, cuVS, and we'll show you a few more. These libraries sit on top of our platform. But ultimately, we integrate into the world's cloud services, into the world's OEMs, and together, and other platforms that I'll show you, together we're able to reach the world. This pattern, NVIDIA, Google Cloud, Snapchat, will repeat over and over again, and it kind of looks like this. And so this is one example, NVIDIA with Google Cloud. We accelerate Vertex AI, we accelerate BigQuery, we accelerate.
그렇죠. 어플리케이션이 GCP처럼 클라우드 사업자를 사용하고 클라우드 사업자가 안에서 엔비디아 하드웨어랑 네, 라이브를 사용해서 더 클라우드를 더 빠르고 좋게 제공한다.
Puma, Salesforce. They're not our customers, but they're customers, developers of ours that we've integrated the NVIDIA technologies into that we can then land on the clouds. Our relationship with cloud service providers are essentially us bringing customers to them. We integrate our libraries, we accelerate workloads, and we land those customers in the clouds. And so, as you could see, most of our
와,
cloud
근데
service providers
VLLM
love
벌써
working
저기
with
들어가
us,
있네.
and they're always asking us to land the next customer on their cloud. And I just
진짜
want to let
대단하긴
you know,
해요. 저런
lot of
서빙
customers.
프레임워크가 이렇게 힘을
We're gonna
벌써 영향력을
accelerate
가진다는
everybody.
게.
And so there'll be lots and lots of customers who will be able to land in your cloud. Just be patient with us. And so this is Google Cloud. This is AWS. We've been working with AWS a long
그렇죠.
time.
GCP
And one of
말고
the areas-
AWS도 당연히 똑같이
one of the things
하겠죠.
I'm super excited about this year is we're going to bring OpenAI to AWS. And so it's going to drive enormous consumption of cloud computing at AWS. It's going to expand the reach.
오픈AI
expand the
애저만 하는 게
compute
아니라
of
AWS 한다고요?
OpenAI. And as you know, they are completely compute constrained. And so AWS, we accelerate EMR,
어쩐지 요새
we
많이
accelerate
터지더니 안 그래도
SageMaker,
코덱스 지난주에
we
진짜
accelerate
계속 터져 있어가지고
NVIDIA's
잘 못
integrated
썼는데
really deeply into AWS. They were our first cloud partner. Microsoft Azure. NVIDIA's
그죠, 애저.
A100 supercomputer was the first one we built was for NVIDIA.
근데 갑자기
The first one
애저에도
we
엔트로픽이
installed
있네.
was at Azure, and that led to the big successful partnership with OpenAI. But we've been working with Azure for quite a long time. We accelerate Azure Cloud. Now it's their AI
그쵸.
Foundry.
오픈AI가 애저 쓰고 애저가 엔비디아 GPU 써서 그 GPT 다 만들고 그렇게 했다고 다들 알고 있죠.
This is one of the areas that is incredibly important as we continue to expand AI throughout the world. One of the capabilities that we offer is confidential computing. That in confidential computing, you want to make sure that even the operator cannot see your data. Even the operator cannot touch or see your models. Confidential computing, NVIDIA's GPUs is the first ones in the world to do that. It's now able to support confidential computing and protected deployment of
그래요?
very
컨피덴셜
valuable
컴퓨팅?
OpenAI
이런 건
models
처음 듣네?
and Anthropic models.
오퍼레이터 그러니까 애저나 엔트로픽이나 이런 애들도 안에서 무슨 데이터가 돌아가는지 모르게 하겠다. 말이 되나요? 가능한가?
Where we have different customers that we work with. Synopsys, a great partner of ours, we're accelerating all of their EDA and CAE workflows. And then we landed at Microsoft Azure. We were Oracle's first AI customer. Most people would have thought we were their first supplier. We were their first supplier also, but we were their first AI customer.
컨피덴셜 컴퓨팅. 제 채팅창에 메모를 해놓을게요. 이거 뭔가 좀 이상한데?
AI clouds to Oracle for the first time, and we were their first customer. Since then, they've really taken off. We've landed a whole bunch of our partners there, Cohere and Fireworks, and of course, very famously, OpenAI. A great partnership with CoreWeave. They're the world's first AI native cloud, a company that was built with only one singular purpose, to provision, to host GPUs as the era of accelerated computing showed up, and to host for AI
CoreWeave.
clouds.
네, 이거는
They've got some
뭐
fantastic customers.
계속
And
이제
they're
하나씩
growing
추가
incredibly.
다 자기네
One of the
커스터머 자랑할
platforms that I'm
테니까
quite excited about
댓글에 대해서
is
답변을
Palantir and
드리자면
Dell.
블랙웰로 초기 버전? 그게 무슨 뜻일까요? GPT 어제 옛날부터 학습해둔 건데 블랙웰로 지금 학습된 게 하나 둘씩 나오고 있다는 뜻이겠죠? 그럼 베랄 루빈으로 학습된 게 또 이제 지금 돌고 있을 테니까 그 다음에 나올 거니까 4배 정도는 추천 지능. 추천 지능을 어떻게 정량화할지 일단 좀 어려울 것 같고요. 그냥 뭐 똑똑해지고 싸지겠죠. 그거는 이제 거의 확실한 것 같죠. 몇 배? 이거는 좀 가늠하기가 어려운 것 같아요. 아무튼 그냥 계속 똑똑해지고 싸진다. 그거 확실하다. 이 정도는 확신할 수 있을 것 같아요.
I wanted to show you these
오,
examples.
가우스. 하이.
This is our special working relationship with the world's cloud service providers. And many, well, all of them are here. And I get the benefit of seeing them during booth tour, and it's just so incredibly exciting. I just want to thank all of you for the hard work. What NVIDIA has done is this, and you're going to see this theme over and over again. NVIDIA is vertically integrated, the world's first vertically integrated but horizontally open company. And the reason that's necessary is very simple. Accelerated computing is not a chip problem. Accelerated computing is not a systems problem. Accelerated computing has a missing word. We just never say it anymore. Application acceleration. If I could make a computer run everything faster, that's called
네.
a CPU.
어쨌든 열심히
But that's
자랑하십니다.
run out of steam.
Accelerating computing, 컴퓨팅 빠르게 하는 게 중요한 문제다. 그래서 우리가 거의 모든 GCP 같은 클라우드 사업자, GCP든 뭐 애저든 AWS든 다 자기네 GPU를 쓰고 있다. 왜냐하면 Accelerated Computing이라는 문제가 되게 중요하고 자기네들만 할 수 있는 문제니까. 오케이.
We are a vertically integrated computing company. There is no other way. We have to understand the applications, we have to understand the domain, we have to understand fundamentally the algorithms, and we have to figure out how to deploy the algorithm in whatever scenario it wants to be deployed.
알고리즘 잘 알아야지 컴퓨팅 액셀레이팅 할 수 있다. 자기네들이 제일 잘한다. 마치 AMD는 잘 못한다. 뭐 이런 소리를 하는 것만 같죠? 그렇게 들리네요.
What makes it incredibly powerful, and the reason why you saw all the slides, is because NVIDIA is horizontally open. We'll work and integrate NVIDIA's technology into
우린
whatever
아무데나 다
platform you would
들어간다.
like us to integrate into.
호리젠탈 하게는 다 오픈되어 있다. 누구든 우리 거 다 가져다 쓸 수 있다.
Your technology so that we can bring accelerated computing to everybody in the world. Well, this GTC is really a great demonstration of that. You know, most of the time you'll see me talk about these verticals, and I'll use some examples. But in every single case, whether it's
모든 vertical에 대해서 이제 하나씩 설명을 할 것 같아요.
The largest percentage of attendees at this GTC is from the financial services industry. I know. I'm hoping it's developers, not traders. Guys. Here's one thing I wanted to say. And so in the audience
개발자 행사라고.
represents NVIDIA's ecosystem upstream of our supply chain and downstream of our supply chain. And we think about our supply chain upstream and downstream. And it's just so exciting that our entire upstream supply chain this last year, irrespective of whether you're a 50-year-old company, we have 70-year-old companies, we have a 150-year-old company who are now part of NVIDIA's supply chain and partnering with us either upstream or downstream. And last year, you had your record year. Did you not? Congratulations. We're on to something here. This is the beginning of something very, very big. And so, if you look at accelerated computing, we've now set the computing
갑자기
platform.
박수유도.
But in order for us to activate those computing platforms, we need to have domain-specific libraries that solve very important problems in each one of the verticals that we address. You see us addressing every single one of this. Autonomous vehicles, our reach, our breadth, our impact, incredible. We have a track on that. Financial services, I just mentioned. Algorithmic trading is going from classical machine learning with human featured engineering called the quants did that, to now supercomputers studying massive amounts of data, discovering insight and discovering patterns by itself. And so this is going through its deep learning and its transformer moment. Healthcare is going through their ChatGPT moment. Some really exciting work that we're there. We have a great keynote track here. We have a great keynote track. Kimberly Powell's doing a great keynote track for healthcare. We're talking about AI physics or AI biology for drug discovery, AI agents for customer service and support of diagnosis. And of course, physical AI, robotic systems. All these different vectors of AI have different platforms that NVIDIA provides. Industrial, we are completely resetting and starting the largest build-out of human history. And most of the world's industries, building AI factories, building chip plants, building computer plants, are represented here today. Media and entertainment, gaming, of course, real-time AI platform so that we could translation and broadcast support and live games and live video. Enormous amount of it will be augmented with AI. We have a platform called Holoscan. Quantum, there are 35 different companies here building with us the next generation of quantum GPU hybrid systems. Retail and CPG, using NVIDIA for
옵티컬
supply
인터커넥트
chain,
얘기 안 나왔습니다.
creating agentic shopping systems, AI agents for customer support.
아, 영어로 해야 되나요? There were no mentions about optical interconnects. 제가 여기 있는 거 웬만한 건 다 이해가 가는데 저 퀀텀 컴퓨팅 하나만큼은 진짜 무슨 소린지 하나도 모르겠어요. 뭐 하긴 하는 거예요.
Working with literally every single company that we know of building robots. We have 110 robots here at the show. And then telecommunications. About as large as the world's IT industry, about $2 trillion. We see, of course, base stations everywhere. It's one of the world's infrastructures. It was the infrastructure of the last generation of computing. That infrastructure is going to get completely reinvented. And the reason for that is very simple. That base station, which is, it does one thing, which is base station, is going to be an AI infrastructure platform in the future. AI will run at the edge. And so lots of great discussion there. And our platform there is called Aerial or AI RAN. Big partnership with Nokia, big partnership with T-Mobile and many others. At the core of our business, everything that I just mentioned, computing platforms, but very importantly, our CUDA-X libraries. Our CUDA-X libraries is the algorithms that NVIDIA invents. We are an algorithm company. That's what makes us special. That's what makes it possible for me to be able to go into every single one of these industries, imagine the future, and have the world's best computer scientists describe and solve problems, refactor it, re-express it, and turn it into a library. We have so many. I think we have, at this show, we're announcing 100 libraries, 70 libraries, maybe 40 models. And that's just at the show. We're updating these all the time. We're updating them all the time. The libraries is the crown jewels of our company. It is what makes it possible for that platform, the computing platform, to be activated in service of solving a problem, making impact. One of the most important libraries that we ever created, cuDNN, CUDA Deep Neural Networks. It completely revolutionized artificial intelligence, caused a big bang
진짜
of modern
대학생
AI.
때 진짜
Let me show
열심히
you a short
했었는데.
video about CUDA-X.
20 years ago, we built CUDA, a single architecture for accelerated computing. Today, we've reinvented computing. 1,000 CUDA-X libraries help developers make breakthroughs in every field of science and engineering. cuOpt for decision optimization. cuLitho for computational lithography. cuDSS for direct sparse solvers. cuEquivariance for geometry-aware neural networks. Aerial for AI RAN, Warp for differentiable physics, Parabricks for genomics. At their foundation are algorithms, and they are beautiful.
코스모스 젠 나오네요. 나이트힐. 오, 파우나 나왔다. A 로봇도 나오네. 이제 여러 번 봤던 거죠, 이거. 근데 이거 지금 다 시뮬레이션을 보여주려고 하는 것 같은데 뭔가 시뮬레이션이 아닌 것 같은 것도 많이 섞여 있는 것 같아요. 네, 아까 보던 거죠. 문 안 열어서 드라이 베이비. 지구까지 시뮬레이션을 하겠다. 오케이.
Everything you saw was a simulation. Some of it was principled solvers.
팬텀 MK1?
Fundamental
이게 뭘까요?
physics solvers. Some of it was AI surrogates, AI physical models, and some of it was physical AI robotics models. Everything was simulated. Nothing was animated. Nothing was articulated. Everything was completely simulated. That
애니메이션 아니고 다 시뮬레이티드였다고요? 그래요? 뭐 믿기진 않는데 그런가 봐요.
Understanding of the algorithms with our computing platforms that we're able to open up to unlock these opportunities. NVIDIA is a vertically integrated computing company with open horizontal integration with the world. So that's CUDA X. Well, just now you saw a whole bunch of companies. You saw Walmart and there's L'Oreal and incredible companies, established companies, JP Morgan and Roche. And these are companies that have defined society to today. Toyota is here. These are some of the largest companies in the world. It is also true that there's a whole bunch of companies you've never heard of. These are companies, we call them AI natives. A whole bunch of small companies. The list is gigantic. I couldn't. This is just a little tiny bit of it. And
야, SGL, VLLM 다
show you
있어요.
more, show you less. And so I made it so that you couldn't see any. And nobody's feelings are hurt. However, inside this list are a bunch of brand new companies. They're companies like, for example, you might have heard a couple of them, OpenAI, Anthropic, but there's a whole bunch of others. There's a whole bunch of others, and they serve different verticals. Something happened in the last 2 years, particularly this last year. We've been working with the AI natives for a long time, and this last year, it just skyrocketed. I'll explain to you why it happened. This industry has skyrocketed. $150 billion of investment into venture investment, into startups, the largest in human history. This is also the first time that the scale of the investments went from millions of dollars, tens of millions of dollars, to hundreds of millions of dollars and billions of dollars. And the reason for that is this is the first time in history that every single one of these companies needs compute, and lots of it. They need tokens, lots and lots of it. They're either going to create and build and create tokens and generate tokens, or they're going to integrate, add value to tokens that are available, created by Anthropic and OpenAI and others. And so this industry is different in so many different ways, but the one thing that is very clear, the impact that they're making, the incredible value that they're delivering already is quite tangible. AI natives, all because we reinvented computing. Just like during the PC revolution, a whole bunch of new companies were created. Just as during the internet revolution, a whole bunch of companies were created. In the mobile cloud, a whole bunch of companies were created. Each one of them had their own standards. And we're talking about one of the major standards that just happened, incredibly important. And this generation, we also have our own large number of very, very special companies. We reinvented computing. It stands to reason there's going to be a whole new crop.
네, 어쨌든 뭐 엔비디아가 잘해서 오픈앤 엔트로픽 뭐 이런 거 잘 만들어져가지고 그거 토큰 써서 2년 동안 새로운 엄청 막에 많은 회사들이 쭉 다 탄생을 했다. 그리고 거기에 진짜로 투자금이 많이 들어가고 있다. 그 걔네들이 다 저 작은 AI 네이티브 컴퍼니들이 다 토큰을 쓸 거고 그거는 다 엔비디아 GPU에서 돌아갈 거다. 뭐 이런 이야기를 하네요.
What happened in the last 2 years? Well, three things. ChatGPT, of course, started the generative AI era. It's able to not just
네, ChatGPT 생겼고요. O1 클로드 코드.
It's able
오케이.
to also translate and generation of unique content. I showed you the fusion of generative AI with computer graphics, and it brought computer graphics to life. You guys, just everybody in the world should be using ChatGPT. I know I use it every single morning, used it plenty this morning. And so ChatGPT was the generative AI era. The second, by the way, generative computing versus the way we used to do computing, it's generative AI is a capability of software, but it has profoundly changed how computing is done. Computing used to be retrieval-based, now it's generative. Keep that thought in mind when I talk about certain things, and you'll realize why it is that everything that we do is going to change how computers are architected, how computers are provided, how computers are going to be built out, and what is the meaning of computing altogether. Generative AI, 2023, end of 22.
컴퓨팅 자체가 좀 많이 달라졌다. 왜냐면 어플리케이션일 뿐일 때 사실 AI가 그거 하도 많이 쓰니까 걔는 필요한 컴퓨팅이 좀 달라서 그렇다 뭐 이런 이야기죠.
Break down problems and decompose a problem it couldn't understand into steps or parts that it could understand. It could ground itself on research. O1 made generative AI trustworthy and grounded on truth. That caused ChatGPT to simply took off. And that was a very, very big moment. The amount of input tokens that was necessary in order to produce and the amount of output tokens it generated in order to reason. The model was a little bit larger. Of course, you could have much larger models. The model O1 was a little bit larger, not much larger. But its input token usage for context and its output token for thinking increased the amount of computation tremendously. Then came Claude Code, the first agentic model.
네, 토큰 사용량이 팍팍팍 늘어날 거라고 당연히 다 생각을 하고 있었지만 저렇게 그냥 딱 진짜 하나씩 딱 보여주네요. 10배씩, 1년에 10배씩.
Code has revolutionized software engineering, as all of you know. 100% of NVIDIA is using a combination of, or oftentimes all three of them, Claude Code, Codex, and Cursor, all over NVIDIA. There's not one software engineer today who is not assisted by one or many
아니구나.
AI
모델이랑
agents helping them
컨텍스트가
code.
10배고
Claude Code completely revolutionizes
모델
the
10배,
new inflection. And for the first time,
토큰
you
10배.
don't ask a
맞네.
AI
근데 뭐
what, where, when, how. You ask it create, do, build. You ask it to use tools, take your context, read files. It's able to agentically break down a problem, reason about it, reflect on it. It's able to solve problems and actually perform tasks. An AI that was able to perceive became an AI that could generate. An AI that could generate became an AI that could reason. An AI that could reason now became an AI that can actually do work, very productive work. The amount of computation in the last 2 years, we know that everybody in this room knows the computing demand for NVIDIA GPU is off the charts. Spot pricing is skyrocketing. You couldn't find a GPU if you tried, and yet, in the meantime, we're shipping GPUs out. Incredible amounts of it, and demand just keeps on going up. There's a reason for that. This fundamental inflection. Finally, AI is able to do productive work, and therefore, the inflection point of inference has arrived. AI now has to think. In order to think, it has to inference. AI now has to do. In order to do, it has to inference. AI has to read. In order to do so, it has to inference. It has to reason. It has to inference. Every part of AI, every time it has to think, it has to reason, it has to do, it has to generate tokens, it has to inference. It's way past training now. It's in the field of inference. So the inference inflection has arrived. At the time when the amount of tokens, the amount of compute necessary increased by roughly 10,000 times. Now, when I combine these two, the fact that since in the last 2 years, the computing demand of the work has gone up by 10,000 times, and the amount of usage has probably gone up by 100 times. People have heard me say, I believe that computing demand has increased by 1 million times.
근데 저만 해도 2년 전이랑 지금이랑 쓰는 토큰 양이 몇 배가 차이 날까? 100배보다 훨씬 많이 차이 나는 것 같거든요. 모델만 100배 된 게 아니라 모델은 100배는 안 된 것 같고 오히려 토큰 사용량 10,000배 차이 나는 것 같은데 과거의 저랑 지금이랑.
Positive flywheel system. We have reached that moment. The inflection, the inference inflection has arrived. Last year, at this time, I said that where I stood at that moment in time, we saw about $500 billion. We saw $500 billion of very high confidence demand and purchase orders for Blackwell and Rubin through 2026. I said that last year.
작년에
Now, I don't know if
매출
you guys
자랑.
feel the same way, but $500
누구나 다 알고
billion
있는 진짜 말도 안 되는
is an enormous
금액의
amount of revenue.
수요가 있었다는 거죠.
Not one impressed. I know why you're not impressed, because all of you had record years. Well, I'm here to tell you
모두가 다 알고 있죠.
that right now where I stand, a few short months after GTC DC, 1 year after last GTC, right here where I stand, I see through 2027 at least $1 trillion.
2배. 네, 2배 팔릴 거라고요. 1년 만에. 아직도 2배를 성장한다.
Now, does it make any sense And that's what I'm going to spend the rest of the time talking about. In fact, we are going to be short. I am certain computing demand will be much higher than that. And there's a reason for that. So the first thing is, we did a lot of work in the last year. Of course, as you know, 2025 was NVIDIA's year of inference. We wanted to make sure that not only were we good at training and post-training, that we were incredibly good at every single phase of AI, so that the investments that were made, investments made in our infrastructure, could scale out for as long as they would like to use it. And the useful life of NVIDIA's infrastructure would be long, and therefore the cost would be incredibly low. The longer you could use it, the lower the cost. There's no question in my mind. NVIDIA systems are the lowest cost infrastructure you could get for AI infrastructure in the world. And so the first part was, last year was all about AI for inference, and it drove this inflection point. Simultaneously, we were very pleased last year that Anthropic has come to NVIDIA, that MSL, Meta SL, has chosen NVIDIA. And meanwhile, and as a collection, as a group, this represents 1/3 of the world's AI compute, open source models. Open source models have reached near the frontier, and it is literally everywhere. And NVIDIA, as you know, today, we're the only platform in the world today that runs every single domain of AI across every single one of these AI models, in language and biology, in computer graphics, computer vision, in speech, proteins and chemicals, robotics and otherwise, edge or cloud, any language. NVIDIA's architecture is fungible for all of that, and we're incredible for all of that. That allows us to be the lowest cost, the highest confidence platform. Because when you're building these systems, as I mentioned, $1 trillion is an enormous amount of infrastructure. You have to have complete confidence that the $1 trillion you're putting down will be utilized, would be performant, would be incredibly cost effective, and have useful life for as long as you could see. That infrastructure investment you could make on NVIDIA, you could make with complete confidence. We have now proven that. It is the only infrastructure in the world that you could go anywhere in the world and build with complete confidence. You want to put it in any of the clouds, we're delighted by that. You want to put it on-prem, we're happy about that. You want to put it in any country, anywhere, we're delighted to support you. We are now a computing platform that runs all of AI. Now, our business already starting to show that. 60% of our business is hyperscalers, the top 5 hyperscalers.
저런 거 궁금했는데 뭐 찾으면 알 수는 있었겠지만 60%가 하이퍼스케일러가 산다고 하네요. 60%보다 훨씬 클 거라고 생각했는데 그렇진 않네요.
Recommender systems of tables and collaborative filtering and content filtering, it's moving towards deep learning and large language models. Search, moving to deep learning, large language models. Almost all of these different hyperscale workloads are now moving, shifting towards a workload that NVIDIA GPUs are incredibly good at. But on top of that, because we work with every AI lab, because we work with every AI, we accelerate every AI model, and because we have a large ecosystem of AI natives that we work with that we can bring to the clouds, that investment, no matter how large, no matter how quick, that compute will be consumed.
아, 나머지 40%의 소버린 AI, 엔터프라이즈 인더스트리얼 이런 게 있구나. 저건 하이퍼스케일러가 아니네요.
Enterprise, industrial, robotics, edge, big systems, supercomputing systems, small servers, enterprise servers. The number of
저
systems,
소버린 AI의 우리나라 지분이 꽤 크겠지?
the diversity of AI is also its resilience. The span of reach of AI is its resilience. There is no question this is not a one-app technology. This is now fundamental. This is absolutely a new computing platform shift. Well, our job is to continue to advance the technology, and one of the most important things that I mentioned last year was our year of inference. We dedicated everything. We took a giant chance and reinvented while Hopper was at its prime and it was just cooking. We decided that the Hopper architecture, the NVLink by 8, had to be taken to the next level. We completely re-architected the system, disaggregated the computing system altogether, and created NVLink 72. The way that it's built, the way it's manufactured, the way it's programmed completely changed. Grace Blackwell NVLink 72 was a giant bet, and it wasn't easy for anybody. And many of my partners here in the room, I want to thank all of you for the hard work that you guys did. Thank you. NVLink 72, NVFP4, not just FP4 precision, FP4 is a whole different type of tensor core and computational unit. We've demonstrated now that we can inference NVFP4 without loss of precision, but gigantic boost in performance and energy efficiency.
그러게요. NVFP4 블랙을 나올 때 저 4빗 나오고 GPT OSS 4빗 4.25빗 네. 이렇게 맞춰서 나올 때만 해도 아 진짜 이거 4빗으로 연산하는데 이게 되는 게 맞나? 이런 생각 많이 했는데
We invested billions of dollars of supercomputing capability help us create the kernels, the software that made inference possible. Well, the results all came together, and people used to tell me, but Jensen, inference is so easy. Inference is the ultimate hard. Inference is ultimate hard. It is also ultimate important because it drives your revenues. And so this is the outcome. This is from semi-analysis. This is the largest, most comprehensive sweep of AI inference that has ever been done. And what you see here on the left, on this side, is tokens per watt. Tokens per watt is important because
이제 전기 사용량으로
every single factory by
보죠.
definition is power
GB300, NVLink
constrained.
72.
Factory will never become two. It's physically
한 칩 아니고
the laws of atoms, the laws of physicality.
GB300, B300은 뭐지?
Gigawatt of data center, you want to drive the maximum number of tokens, which is the production, the product of that factory. So you want to be on top of that curve as high as you want. The x-axis is the interactivity, the speed of inference, the speed of each inference.
User per token, token per speed.
The faster you could, of course, respond.
per
But
유저?
very importantly, the
유저당
faster you
토큰
can
per speed?
inference, the larger the models, the more context you could process, the more tokens you can think through. This axis is the same as smartness of the AI. And so this is the throughput of the AI. This is the smartness of the AI. Notice, the smarter the AI, the lower your throughput. Makes sense. You're thinking longer. Okay? And so this axis is the speed, and I'm going to come back to this. This is important. This is where I torture all of you. But it's too important. Every CEO in the world, you watch, every CEO
저건
in the
뭐야?
world
갑자기
will study their business from now on
이상한
in the way I'm
개념을
about to
가져오네.
describe. Because this is your token factory. This is your AI factory. This is your revenues. There's no question about that going forward. And so this is the throughput. This is the intelligence. Better perf per watt for a given power of data center, the more throughput, the more tokens you could produce. On this side is cost. Notice, NVIDIA is the highest performance in the world. Nobody would be surprised by that. They would be surprised by the fact that in one generation, whereas Moore's law would have given us, through transistors,
TPS per 유저. 저건 뭐지?
Moore's law would probably give us 1.5 times more performance. You would have expected from Hopper H200 1.5 times higher. Nobody would have expected 35 times higher. I said last year at this time that NVIDIA's Grace Blackwell NVLink 72 was 35 times perf per watt. Nobody believed me. And then semi-analysis came out, and Dylan Patel had a quote. He accused me of sandbagging.
갑자기
He accused
파텔이
me of sandbagging. He says, Jensen sandbagged. It's actually 50 times. And he's not wrong. He's not wrong. And so our cost per token, our cost per token is the lowest in the world. You can't beat it. I've said before, if you have the wrong architecture, even if it's free, it's not cheap enough. And the reason for that is because no matter what happens, you still have to build a gigawatt data center.
샌드베깅이
You still
뭐예요?
have to build a gigawatt factory. And that gigawatt factory, for 15 years amortized across, that gigawatt factory is about $40 billion. Even when you put nothing on it, it's $40 billion in. You better make for darn sure you put the best computer system on that thing so that you could have the best token cost. NVIDIA's token cost is world-class, basically untouchable at the moment. And the reason that's true is because of extreme co-design. And so I'm very happy that he named us
저거 하려고 인퍼런스 맥스킹.
There was a Monkey King, Token King. Well, we take all of our software, as I told you, we vertically integrate, but we horizontally open. We're vertical integration, horizontal open.
귀엽긴 해요. 저거
We integrate
준비해온
all
거.
of our software and all of our technology, however we could package it up and integrate it into the world's inference service providers. And these companies are growing so fast. They're growing so fast. Fireworks, Lynn is here, Together, they're just growing so incredibly fast. 100 times in the last year. They are token factories. And the effectiveness, the performance, and the token cost production capability for their factories is everything to them. And this is what happened. We updated their software, same system, and notice their token speeds, incredible. The difference before NVIDIA updated everything and all of our algorithms and software and all the technology that we bring to bear, about 700 tokens per second average went to nearly 5,000, 7 times higher. And so this is the incredible power of extreme co-design. I mentioned earlier the importance of factories. This is the importance of factory. Your data center, it used to be a data center for files. It's now a factory
키비 K2를
to
기준으로
generate tokens.
TPS를 측정하네요.
Your factory is
진짜
limited
키비
no matter
K2를
what.
많이 쓰나 봐요.
Everybody's looking for land, power, and shell. Once you build it, you are power limited. Within that power limited
1트릴리언 모델이라서 그런 건가? 제일 큰 거라서 그런가?
Because you know inference is your workload and tokens is your new commodity, that compute is your revenues, that you want to make sure that the architecture is as optimized as you can. In the future, every single CSP, every single computer company, every single cloud company, every single AI company, every single company period are going to be thinking about their token factory effectiveness. This is your factory in the future. And the reason why I know that is because everybody in this room is powered by intelligence. And in the future, that intelligence will be augmented by tokens. So let me show you how we got here.
On April 6th, 2016, a decade ago, we introduced DGX-1, the world's
첫
first
번째
computer
GGX
designed
오픈AI에
for
들어갔던 그거 같죠?
8 Pascal GPUs connected with the first generation NVLink. 170 teraflops in one computer. The world's first computer designed for AI researchers. With Volta, we introduced NVLink Switch. 16 GPUs connected with full all-to-all bandwidth, operating as one giant GPU. A giant step forward, but model sizes continued to grow. The data center needed to become a single unit of computing. So Mellanox joined NVIDIA. In 2020, DGX A100 SuperPod became the first GPU supercomputer combining scale-up and scale-out architecture. NVLink 3 for scale-up, Connect X6, and Quantum InfiniBand for scale-out.
인피니밴드 나오네요 이제.
Then Hopper, the first GPU with the FP8 transformer engine that launched the generative AI era. NVLink 4, Connect X7, Bluefield 3 DPUs, second generation Quantum InfiniBand. It revolutionized computing. Blackwell redefined AI supercomputing system architecture with NVLink 72. 72 GPUs connected by NVLink Spine. 130 terabytes per second of all-to-all bandwidth. Compute trays integrate Blackwell GPUs, Grace CPUs.
네, 이제 블랙웰은 72개를 하나로 놓는 걸 디폴트로 가져가려고 하죠.
Scale-out runs over Spectrum 4 Ethernet. With 3 scaling laws in full
이제
steam,
노드의 개념이 좀
pre-training,
애매해진 것 같아요.
post-training, and inference, and now agentic systems, compute demand continues to grow exponentially. And now, Vera Rubin. Architected for every phase of agentic AI, advancing every pillar of computing, including CPU, storage, networking, and security. Vera Rubin NVLink 72, 3.6 exaflops of compute, 260 terabytes per second of all-to-all NVLink bandwidth. The engine supercharging the era of agentic AI, the Vera CPU rack, designed for orchestration and agentic workflows. The STX rack, AI native storage built with Bluefield 4. Scale out with Spectrum X co-packaged optics, increasing energy efficiency and resiliency. And an incredible new addition, the Grok 3
헐,
LPX rack.
그록 3가
Tightly
들어왔네.
connected to Vera Rubin, Grok's LPU's massive on-chip SRAM, a token accelerator to the already incredibly fast Vera Rubin.
헐.
Together, 35 times more throughput per megawatt. The new Vera Rubin platform, 7 chips, 5 rack-scale computers, 1 revolutionary AI supercomputer for agentic AI. 40 million times more compute in just 10 years.
아, 그록 3 인수했지 엔비디아가. 그랬죠.
Now, in the good old days,
뭐야.
when I would say Hopper, I would hold up a chip. That's just adorable. This is Vera Rubin. When we think
진짜 저 아이돌 무대에 올리는 것처럼
when we think Vera Rubin, we think the entire
GPU를
system
거의 아이돌처럼 취급하죠.
vertically integrated, completely with software, extended end to end, optimized as one
그록
giant
껴서
system.
파네 이제.
The reason why it's designed for agentic systems is very clear, because agents, of course, the most important workload is it's thinking the large language model. The large language models are going to get larger and larger and larger. It's going to generate more and more tokens more quickly, so it can think more quickly. But it also has to access memory. It's going to pound on memory really hard. KV cache, structured data, QDF, unstructured data, QVS. It's going to be pounding on the storage system really, really hard, which is the reason why we reinvented the storage system. It is also going to use tools. And unlike humans that are more tolerant to slower computers, AI wants the tools to be as fast as possible. These tools, web browsers, in the future, they could also be virtual PCs in the cloud. Those PCs have to be, and those computers have to be as fast as possible. We created a brand new CPU that's designed for extremely high single-threaded performance, incredibly high data output, incredibly good at data processing, and extreme energy efficiency. It is the only data center CPU in the world that uses LPDDR5, and incredible single-threaded performance and performance per watt that is unrivaled. And so we built that so that it could go along with the rest of these racks for agentic processing. And so here it is. This is the Grace Blackwell, no, Vera Rubin, where is it? Here it is, okay? So this is the Vera Rubin system. Notice, since the last time, 100% liquid cooled. All of the cables gone. What used to take 2 days to install now takes 2 hours. Incredible. And so the manufacturing cycle time is going to dramatically reduce. This is also a supercomputer that is cooled by hot water, 45 degrees, which takes the pressure off of the data center, takes all of that cost and all of that energy that's used to cool the data center and makes it available for the system. This is the secret sauce. We're the only company in the world that has today built the sixth generation scale-up switching system. This is not Ethernet. This is not InfiniBand. This is NVLink. This is the sixth generation NVLink.
해서
This is insanely hard
GPU
to
엄청
do
큰
well.
거 여러 개
It is insanely
72니까
hard to do,
72개
period.
묶을 수 있는
And I'm
그런
just super
칩이다.
proud of the team. NVLink,
그다음에 뭐 리퀴드
completely
쿨링
liquid cooled.
자랑하고요.
This is the brand new Grok system, and I'll show you a little bit more
와,
about it.
그럭.
This system, 8 Grok chips. This is the LP30. The world's never seen it. Anything that the world's ever seen is V1. This is 3rd generation. And we're in volume production now. And I'll show you more about that in just a second. The world's first CPO Spectrum X switch. This is also in full production.
아니 그럭 3를 가져본 인퍼런스를 어디서 어떻게 하는 거지?
Interfaces directly to silicon. Electrons get translated to photons, and it gets directly connected to this chip. We invented the process technology with TSMC. We're the only one in production with it today. It's called COUP. It's completely revolutionary. NVIDIA is in full production with Spectrum X. This is the Vera system, twice the performance per watt of any CPUs in the world today. It is also in production. Well, you know, we never thought we would be selling CPUs standalone. We are selling a lot of CPUs standalone. This is already, for sure, going to be a multi-billion-dollar business for us. So I'm very, very pleased with our CPU architects. We've designed a revolutionary CPU. And this is the CX9 powered with Vera CPU, the Bluefield 4 STX, our new storage platform. Okay, so these are the racks, and it's connected. Each one of these racks, the NVLink rack, I've shown you guys this before. It's just super heavy and seems to get heavier every year. Because I think there's just more cables in there every year. And so this is the NVLink rack. We've also taken this technology because it is so efficient to create a data center with these cabling systems, structured cables. So we decided to do that for Ethernet. So this is Ethernet, 256 liquid-cooled nodes in one rack, and it is also connected with these incredible connectors. You guys want to see Rubin Ultra?
루빈 울트라가 새로 나오나 봐요. 올.
So this is the Rubin Ultra compute node. Unlike Rubin that slides in horizontally, Rubin Ultra goes into a whole new rack. It's called Kyber, that enables us to connect 144 GPUs in one NVLink domain. And so the Kyber
144.
rack,
이제 144네.
I
2배 더
could
했나
lift
봐요.
it, I'm sure, but I won't. It's quite heavy. This is one compute node, and it slides into the Kyber rack vertically.
이제 렉에다 호리젠탈하게 안 끼우고 버티컬하게 끼운다고요. 처음 보는 새로운 방식의 렉이네요.
Top NVLink connectors slide in and connect into this, and this becomes one of the nodes. And each one of these racks is a different compute node, and this is the amazing part. This is the midplane. And the back of the midplane, instead of the cabling system, which has its limits in terms of how far we could drive cables, copper cables, we now have this system to connect 144 GPUs. This is the new NVLink. This sits also vertically, and it connects into the midplanes on the back. Compute in the front, NVLink switches in the back, one giant computer. Okay? So that is Rubin Ultra.
근데 진짜 물리적으로 케이블을 잘 배치하는 게 힘든가 봐요. 저렇게까지 하는 걸 보면은.
As I mentioned, how about we take this back down? I need the rest of my slides. Oh, it's coming down? Okay. Thank you, Janine. This is what happens when you don't practice. Okay, all right. So take your time, just don't get hurt. You saw this slide. You know, only on NVIDIA's keynote will you see last year's slide presented again. And the reason for that is I just want to let you know that last year I told you something very, very important. And it's so important, it's worthwhile to tell you again.
중요한 거는 작년이랑 올해랑 슬라이드가 겹친다. 슬라이드 맨날 비슷한 거 쓰니까요.
And every CEO in the world will be tracking it, will be studying it very deeply. It's much, much more complicated than this. It's multidimensional. But you will be studying the throughput and the token speed of your AI factories. The throughput, token speed at ISO power, because that's all the power you have. Throughput and token speed for your factories forever. And that analysis is going to lead directly to your revenues. What you do this year will show up precisely next year as your revenues. And this chart is what it's all about. And I said on the vertical axis, thank you guys. On the vertical axis is throughput. On the horizontal axis is token rate. Today, I'm going to show you this. Because we're now able to increase the token speed, and because model sizes are increasing, because the token length, the context length, depending on the different grades of different application use case, continues to grow from maybe 100,000 tokens input length to
이걸 이해해 봅시다. TPS per user.
The token input length is
이제 뭘
growing,
말하고 싶은
and
건지.
also the output token length is growing. And so all of these play into ultimately the marketing and the pricing of future tokens. Tokens are the new commodity, and like all commodities, once it reaches an inflection, once it becomes mature or becomes maturing, it will segment into different parts. The high throughput, low speed could be used for the free tier. The next tier could be the medium tier. Larger model maybe, higher speed for sure, larger input context length. That translates to a different price point. You could see from all the different services, this one is free, it's a free tier. The first tier could be $3 per million tokens. The next tier could be $6 per million tokens.
GPT MOE 2 트릴리언이라고요?
able to keep pushing this boundary because the larger the model,
저거 뭐야?
the
2
more
트릴리언 저렇게 막 말해도 되는 거야?
context length, more relevant. The higher the speed, the more you can think and iterate smarter AI models. So this is about smarter AI models. And when you have smarter AI models, each one of these clicks allows you to increase the price. So this is $45. And maybe one day there'll be a premium model that allows you, a premium service that allows you to generate token speeds that are incredibly high because you're in a critical path, or maybe you're doing really long research, and $150 per million tokens is just not a thing. So let's translate that. Suppose you were to use 50 million tokens per day as a researcher at $150 per million tokens. As it turns out, as a research team, that's not even a thing. So we believe that this is the future. This is where AI wants to go. This is where it is today. It had to start here to establish the value and establish its usefulness and get better and better and better. In the future, you're going to see most services encompass all of that. This is Hopper. Hopper started, and I moved the chart. This is 50, this is 100. Hopper looks like this. And you would have expected Hopper, the next generation, to be higher, but nobody would have expected it to be that much higher. This is Grace Blackwell. What Grace Blackwell did is, at your free tier, increase your throughput tremendously. However, where you mostly monetize your service, it increased your throughput by 35 times. This is no different than any product that every company makes. The higher the tier, the higher the quality, the higher the performance, the lower the volume, the lower the capacity. And so it is no different than any other business in the world. And so now we're able to increase this tier by 35x. And we introduced a whole new tier. This is the benefit of Grace Blackwell, a huge jump over Hopper. Well, this is what we're doing with.
네, 1트릴리언짜리 키미 K2만 하더라도 트루풋이 그러니까 H백 이런 데서는 진짜 절대 안 나온다는 뜻이겠죠. 근데 그 정도 똑똑은 해야 이제 수익화가 가능한데.
Okay. Now just think what just happened. At every single tier, we increase the throughput. And at the tier where your highest ASP and your most valuable segment, we increased it by 10x. That is the hard work. This is incredibly hard to do out here. This is the benefit of NVLink 72. This is the benefit of extremely low latency. This is the benefit of extreme co-design, that we could shift the entire area up. Now, what does it mean from a customer perspective in the end? Suppose I were to take all of that and I just, multiply it against, suppose I took 25% of my power, used it in a free tier, 25% of my power in the medium tier, 25% of my power in the high tier, and 25% of my power in the premium tier. My data center only has 1 gigawatt. And so I get to decide how I want to distribute.
지금 투자금이나 소비의 단위를 그냥 기가와트 단위로 전기 사용량을 기준으로 잡고 가고 있네요.
The product of all that allows you basically your revenues. The revenues you can generate, assuming this simplistic example, allows Blackwell to generate 5 times more revenue.
그러니까 전기량이 딱 기가와트 팩토리라고 생각을 하면 GPU를 바꾸면 돈을 훨씬 많이 벌 수 있다. 이런 걸 주장하고 싶은 거죠, 지금. 어떤 어플리케이션이든지 간에.
You should get there as soon as you can. And the reason for that is because your cost of tokens goes down and your throughput goes up. Now, but we want even more. We want even more. And so let me just show you back to this. This is, as I told you, this throughput requires a ton of flops. This latency, this interactivity requires enormous amount of bandwidth. Computers don't like extreme amount of flops, extreme amount of bandwidth, because there's only so much surface area for chips that any systems has. And so optimizing for high throughput and optimizing for low latency are, in fact, enemies of each other. And so this is what happened when we combined with Grok. Okay? And so we acquired a team that worked on the Grok chips and licensed the technology, and we've been working together now to integrate the system. This is what that looks like. So at the most valuable tier, we're now going to increase performance by 35x. Now, this very simple chart revealed to you exactly the reason why NVIDIA is so strong in the vast majority of the workloads so far. And the reason for that is because up in this area, throughput matters so much. NVLink 72 is so game-changing. It is exactly the right architecture, and it's even hard to beat, even as you add Grok to it. However, if you extended this chart way out here and you said you wanted to have services that delivers not 400 tokens per second, but 1,000 tokens per second, all of a sudden, NVLink 72 runs out of steam and it simply can't get there. We just don't have enough bandwidth. And so this is where Grok comes in, and this is what happens when we push that out. So it goes out beyond. Thank you.
엠브링크로는 감당 안 되는 더 큰 모델
Goes out beyond
서비스 하고
even the
싶으면
limits
그럭
of what
같은
NVLink
게
72 can do.
필요하다는 거죠.
And if you were to do
SRAM이
that,
엄청 큰.
translate that into revenues relative to Blackwell, Vera Rubin is 5x. If most of your workload is high throughput, I would stick with just 100% Vera Rubin. If a lot of your workload wants to be coding and very high valued engineering, token generation, I would add Grok to it. I would add Grok to maybe 25% of my total data center. The rest of my data
엄청
center
비싸고
is all
좋은
100% Vera Rubin.
그런 모델을 돌리고 싶으면 그럭을 애드온해라. GPU로만 하지 말고 전용 칩을 써라. 그래서 전용 칩을 샀다. 이해가 갑니다.
This is a contrast. The reason why Grok was so attractive to me is because their computing system, a deterministic data flow processor, it is statically compiled, it is compiler scheduled, meaning the compiler figures out when to do the compute, the compute and the data.
이번 발표의 핵심은 그록이었네요. 이거는 생각을 하지 못했네. 인수했다는 건 알고 있었는데.
Scheduled completely in software. There's no dynamic scheduling. The architecture is designed with massive amounts of SRAM. It is designed just for inference, this one workload. Now, this one workload, as it turns out, is the workload of AI factories. And as the world continues to increase the amount of high-speed tokens it wants to generate with super smart tokens it wants to generate, the value of this integration is going to get even higher. And so these are two extreme processors you could see. One chip, 500 megabytes. One Vera Rubin chip, 288 gigabytes. It would take a lot of Grok chips to be able to hold the parameter size of Rubin, as well as all of the context that has to go, the KV cache that has to go along with it. So that limited Grok's ability to really reach the mainstream, to really take off, until we had a great idea. What if we disaggregated inference altogether with a piece of software called Dynamo? What if we re-architected the way that inference is done in the pipeline so that we could put the work that makes perfect sense on Vera Rubin and then offload the decode generation, the low latency, the bandwidth limited, challenged part of the workload for Grok. And so we unified two processors of extreme differences, one for high throughput, one for low latency. It still doesn't change the fact that we need a lot of memory. And so Grok, we're just going to add a whole bunch of Grok chips, which expands the amount of memory it has. And so if you could just imagine, out of a trillion parameter model, we have to store all of that in Grok chips. However, it sits next to NVIDIA Vera Rubin, where we could hold the massive amounts of KV cache that's necessary in processing all of these agentic AI systems. It's based upon this idea of disaggregated inference. We do the prefill, that's the easy part, but we also tightly integrate the decode. So the attention part of decode is done on NVIDIA's Vera Rubin, which needs a lot of math, and the feed-forward network part of it, the decode part, is done, the token generation part is done on Vera Rubin, on the Grok chip. The two of them working tightly coupled together over, today, Ethernet with a special mode to reduce its latency by about half. And so that capability allows us to integrate these two systems. We run Dynamo, this incredible operating system for AI factories on top of it, and you get 35 times increase. 35 times increase, not to mention additional new tiers of inference performance for token generation the world's never seen. So this is it. This is Grok.
야, 섞어서 저렇게 해요? 풀필하고 어텐션은 GPU에서 한 다음에 뒤에
The Vera Rubin systems, including Grok, I want to thank Samsung, who manufactures the Grok LP30 chip for us, and they're cranking as hard as they can.
그록3 삼성 파운드리예요?
Appreciate you guys. We're
진짜로?
in production with the Grok chip, and we'll ship it in the second half, probably about Q3 timeframe. Okay? Grok LPX. Vera Rubin, you know, it's kind of hard to imagine any more customers. You know, and the really great thing is Grace Blackwell's early sampling of it was really complicated because of coming together of NVLink 72, but the sampling of Vera Rubin is just going incredibly well. And in fact, Satya, I think, texted out already that the first Vera Rubin rack is already up and running at Microsoft Azure. And so I'm super excited for them. We're going to keep cranking these things out. We have now set up a supply chain that could manufacture thousands a week of these systems, essentially multi-gigawatts of AI factories per month inside our supply chain. And so we're going to crank out these Vera Rubin racks while we're cranking out the GB300 racks. We are in full production. The Vera CPUs, incredibly successful. And the reason for that is because AI needs CPUs for tool use. And Vera CPU was designed just perfectly for that sweet spot. Incredible for the next generation of data processing. Vera CPU is ideal. The Vera CPU plus CX9 connected into the Bluefield 4 stack. 100% of the world's storage industry is joining us on this system. And the reason for that is because they see exactly the same thing. The storage system is going to get pounded. It's going to get pounded because we used to have humans using the storage systems. We used to have humans using SQL. Now we're going to have AIs using these storage systems. And it's going to store cuDF accelerated storage, cuVS accelerated storage, as well as, very importantly, KV caching. Okay, so this is the Vera Rubin system. Now, what's amazing is this. In just 2 years' time, in a 1 gigawatt factory, in just 2 years' time, in 1 gigawatt factory, using the mathematics that I showed you earlier, whereas Moore's law would have given us a couple of steps, we would have, X-factored the number of transistors, we would have X-factored the number of flops, we would have X-factored the amount of bandwidth. But with this architecture, we're going to take our token generation speed, token generation rate from 2 million to 700 million, 350 times increase. This is the power of extreme co-design. This is what I mean when we integrate and optimize vertically, but then we open it horizontally for everybody to enjoy. This is our roadmap. Very quickly, Blackwell is here, the Oberon system. In the case of Rubin, we have the Oberon system. We're always backwards compatible so that if you wanted to not change anything and just keep on moving through with the new architecture, you could do so. The old system, the standard rack system, Oberon, still available. Oberon is copper scale up, and with Oberon, we could also use optical scale out, optical scale up to expand to NVLink 576. Okay? And so there's a lot of conversation about, is NVIDIA going to copper scale up or optical scale up? We're going to do both. So we're going to have NVLink 144 with Kyber, and then with Oberon, we're going to NVLink 72 plus optical to get to NVLink 576. The next generation of Rubin, with Rubin Ultra, we have the Rubin Ultra chip, which is coming, which is taping out, and we have a brand new chip, LP35. LP35 will, for the first time, incorporate NVIDIA's NVFP4 computing structure. Give you another few X factor speed up. Okay, and so this is Oberon, NVLink 72, optical scale up, and it uses Spectrum 6, the world's first co-packaged optical, and all of this is in production. The next generation from here is Feynman. Feynman has a new GPU, of course. It also has a new LPU, LP40, big step up, incredible new technology. Now, uniting the scale of NVIDIA and the Grok team, building together LP40, it's going to be incredible. A brand new CPU called Rosa, short for Rosalind. Bluefield 5, which connects the next CPU with the next Super NIC CX10. We will have Kyber, which is copper
신기한
scale
게 지금
up.
벌써 들립니다.
We will also have
5만
Kyber
GPU는 LPU를 포함할
CPO
것이다.
scale up. So for the first time, we will scale up with both copper and co-packaged optics. Okay? And so a lot of people have been asking, Jensen, is copper going to still be important? The answer
이런 건
is
진짜
yes.
상상도 못했네.
Jensen, are you
이렇게
going to
하는구나.
scale up optical? Yes. Are you going to scale out optical? Yes. And so for everybody who is in our ecosystem, we need a lot more capacity. And that's really the key. We need a lot more capacity for copper. We need a lot more capacity for optics. We need a lot more capacity for CPO. And that's the reason why we've been working with all of you to lay the foundation for this level of growth. And so Feynman will have all of that. Let me see if I missed everything. That's it. Every single year, brand new architecture. Very quick. Very quickly, NVIDIA went from a chip company to an AI factory company, or AI infrastructure company, AI computing company, these systems. And now we're building entire AI factories. There's so much power that is squandered in these AI factories. We want to make sure that these AI factories come together, designed in the best possible way. Most of these components never meet each other. Most of us technology vendors, now we all know each other. But in the past, we never met each other until the data center. That can't happen. We're building super complex systems. And so we have to meet each other virtually somewhere else. And so we created Omniverse, and the Omniverse DSX world, a platform where all of us can meet and design these gigafactories, gigawatt AI factories, virtually in system. We have simulation systems for the racks for mechanical, thermal, electrical, networking. Those simulation systems integrated into all of our ecosystem partners of incredible tools companies. We also operated, connected to the grid so that we could interact with each other, send each other information so that we could adjust grid power and data center power accordingly, saving energy. And then inside the data center, using Max-Q so that we could adjust the system dynamically across power and cooling and all of the different technologies we all work on together so that we leave no power squandered, so that we run at the most optimal rate to deliver enormous amount of token throughput. There's no question in my mind there's a factor of 2 in here. And the factor of 2 at the scale we're talking about is gigantic. We call this the NVIDIA DSX platform. And just as all of our platforms, there's the hardware layer, there's the library layer, and there's the ecosystem layer. It's exactly the same way. Let's show it to you.
The greatest infrastructure build-out in history is underway.
팩토리를 통째로 팔겠다 이런 이야기 같죠?
AI factories. And every month of delay costs billions in lost revenues. AI factory revenues are equal to tokens per watt. So with power constraints, every unused watt is revenue lost. NVIDIA DSX is an Omniverse digital twin blueprint for designing and operating AI factories for maximum token throughput, resilience, and energy efficiency. Developers connect through several APIs. DSX Sim for physical, electrical, thermal, and network simulation. DSX Exchange for AI factory operational data. DSX Flex for secure, dynamic power management between the grid. And DSX Max Q to dynamically maximize token throughput.
야,
It starts with sim-ready assets from NVIDIA and equipment manufacturers, managed by PTC Windchill PLM. Then, model-based systems engineering is done in Dassault Systems 3D Experience.
저 GPU 서버를 잘 관리하는
to finalize design.
그런 시스템까지 플랫폼으로 해서 한 번에
using
하네요.
Siemens Star CCM Plus for external thermals, Cadence Reality for internal, ETAP for electrical, and NVIDIA's network simulator, DSX Air. And virtually commissioned
이것도 디지털
through
트윈이라고
to ensure
하는구나.
accelerated construction time. When the site goes live, the digital twin becomes the operator. AI agents work with DSX Max-Q to dynamically orchestrate infrastructure. Phaedra's agent oversees cooling and electrical systems, sending signals to Max-Q, which continuously optimizes compute throughput and energy efficiency. Emerald AI agents interpret live grid demand and stress signals and adjust power dynamically. With DSX, NVIDIA and our ecosystem of partners are racing to build AI infrastructure around the world, ensuring extreme resiliency, efficiency, and throughput.
It's incredible, right? Well, Omniverse was designed to hold the world's digital twin, starting from the Earth. And it's going to hold digital twins of all sizes. And so we have just such a great ecosystem of partners. I want to thank all of you. All of these companies are brand new to our world. We didn't know many of you just a couple of years ago. And now we're working so close together to work on and build together the largest computer the world's ever seen, and also to do it at planetary scale. So NVIDIA DSX is our new AI factory platform.
뭔가 팩토리의 개념이 바뀌는 것 같아요. 팩토리의 생산품이 지금 토큰이 되고 있죠.
However, we're going to space. We've already been out in space. Thor is radiation approved, and we're in satellites. You do imaging from satellites. In the future, we'll also build data centers in space. Obviously, very complicated to do so. We're working with our partners on a new computer called Vera Rubin Space One. And it's going to go out to space and start data centers out in space. Now, of course, in space, there's no conduction, there's no convection, there's just radiation. And so we have to figure out how to cool these systems
스페이스
out in
모델.
space. But we've got lots of great engineers working on it. Let me talk to you about something new.
오픈클로.
So Peter Steinberger's here, and he wrote a piece of software. It's called OpenClaw, and I don't know if he realized how successful it's going to be, but the importance is profound. OpenClaw is the #1, it's the most popular open source project in the history of humanity, and it did so in just a few weeks.
네, GitHub 스타가 리눅스를 앞질렀나 봐요.
It exceeded what Linux did in 30 years. And it's that important. It is that important. It will do, well, this is all you do. Okay? We're announcing our support of it. Let me just
니모클로 이래서 우리한테 니모처럼 해달라고 했구나.
We type this into a console, and it goes out, it finds OpenClaw, it downloads it, it builds you an AI agent, and then you could tell it whatever else you need to do. Okay? So let's take a look.
갑자기 소압이 나오죠?
An open source project just dropped.
Andre Carpathian has just launched something called the research is a huge
오토 리서치 얘기하네요. 오토 리서치 지금 편집 중인데.
Keeping what works and killing what doesn't.
I really love what my stuff enables that person to do. And we had like one guy, he told me like he installed it as his 60-year-old dad, and like they made beer, connected the machine via Bluetooth to OpenClaw, and then we automated everything, including the whole website for people to order.
Lobsterlager fertig sein.
Hundreds of people are queuing up for lobsters in Shenzhen.
OpenClaw. We want to build OpenClaw with OpenClaw.
Everyone is talking about OpenClaw, but what is OpenClaw?
Believe it or not, there's already a Claw Con.
저는 오픈클로 스타 안 눌렀는데 스타를 눌러야 될 것만 같네요.
I illustrated effectively what OpenClaw is in this way, and so that all of you can understand it. But let's just think what happened. What is OpenClaw? It connects. It's an agentic system. It calls and connects to large language models. So the first thing it has resources that it manages. It could access tools. It could access file systems. It could access large language models. It's able to do scheduling. It's able to do cron jobs. It's able to decompose a prompt that you gave it into step by step by step. It could spawn off and call upon other sub-agents. It has I/O. You could talk to it in any modality you want. You could wave at it and it understands you. You could talk to any modality you want. It sends you messages. It texts you, sends you email. So it's got I/O. What else does it have? Well, based on that, you could say, in fact, it's an operating system. I've just used the same syntax that I would describe an operating system. OpenClaw has open sourced essentially the operating system of agentic computers. It is no different than how Windows made it possible for us to create personal computers. Now OpenClaw has made it possible for us to create personal agents. The implication is incredible. The implication is incredible. First of all, the adoption says something, all in itself. However, the most important thing is this. Every single company now realize, every single company, every single software company, every single technology company, for the CEOs, the question is, what's your OpenClaw strategy? Just as we need to all have a Linux strategy, we all needed to have an HTTP, HTML strategy, which started the internet. We all needed to have a Kubernetes strategy, which made it possible for mobile cloud to happen. Every company in the world today needs to have an OpenClaw strategy, an agentic system strategy. This is the new computer. Now, this is just the exciting part. This is enterprise IT before OpenClaw, and I mentioned earlier, the way enterprise IT works, and the reason why it's called data centers is because these large rooms, these large buildings held data, held the files of people, the structured data of business. It would pass through software that has tools and systems of records and all kinds of workflow that's codified into it, and that turns into tools that humans would use. Digital workers would use. That is the old IT industry. Software companies creating tools, saving files, and of course, GSI's consultants that help companies figure out how to use these tools and integrate these tools. These tools are incredibly valuable for governance and security and privacy and compliance, and all of that continues to be true. It's just that post-OpenClaw, post-agentic, this is what it's going to look like. This is the extraordinary part. Every single IT company, every SaaS company will become a gas company. No question about it. Every single SaaS company will become a gas company, an agentic as a service company. And what's amazing is this, OpenClaw gave the industry exactly what it needed at exactly the time. Just as Linux gave the industry exactly what it needed at exactly the time, just as Kubernetes showed up at exactly the right time, just as HTML showed up. It made it possible for the entire industry to grab onto this open source stack and go do something with it. There's just one catch. Agentic systems in the corporate network can have access to sensitive information, it can execute code, and it can communicate externally. Just say that out loud, okay? Think about it. Access sensitive information, execute code, communicate externally. You could, of course, access employee information, access supply chain, access finance information, sensitive information, and send it out, communicate externally. Obviously, this can't possibly be allowed. And so what we did was we worked with Peter. We took some of the world's best security and computing experts, and we worked with Peter to make OpenClaw enterprise secure and enterprise private capable. And we call that,
NemoClaw.
this is our NVIDIA OpenClaw reference for NemoClaw, which is a reference for OpenClaw, and it has all these agentic AI toolkits, and the first part of it is technology we call OpenShell that has now been integrated into OpenClaw. Now it's enterprise ready. This stack,
벌써 enterprise ready라고요?
with a reference design we call NemoClaw, okay? With a reference stack we call NemoClaw, you could download it, play with it, and you could connect to it the policy engine of all of the SaaS companies in the world. And your policy engines are super important, super valuable. So the policy engines could be connected. NemoClaw or OpenClaw with OpenShell would be able to execute that policy engine. It has a network guardrail. It has a privacy router. And as a result, we could protect and keep the claws from executing inside our company and do it safely. We also added several things to the agentic system. And one of the most important things you want to do with your own custom claws is so that you can have your custom models. And this is NVIDIA's Open Model Initiative. We are now at the frontier of every single domain of AI models. Whether it's Nemotron, Cosmos World Foundation model, Groot, artificial general robotics, humanoid robotics models, Alpamayo for autonomous vehicle, BioNemo for digital biology, Earth-2 for AI physics. We are at the frontier on every single one. Take a look.
네, 모델 자랑 이제
The world
모델도
is
엄청
diverse.
열심히 만들고 있죠.
No single model can serve every industry. Open Models is one of the largest and most diverse AI ecosystems in the world. Nearly 3 million open models across language, vision, biology, physics, and autonomous systems enable AI builds for specialized domains. NVIDIA is one of the largest contributors to open source AI. We build and release 6 families of open frontier models, plus the training data, recipes, and frameworks to help developers customize and adopt.
데이터랑
New
레시피를
leaderboard
공개해
topping
주는
models
게 참
are
좋은 것
launching for
같아요.
every family. At the core, Nemotron, reasoning models for language, visual understanding,
아니 울트라
RAG,
안 나왔잖아.
safety,
좀 기다리라면서.
and speech,
Can you hear me now?
Yes.
Hello?
Yes, I can hear you now.
Cosmos, frontier models for physical AI world generation and understanding. Alpamayo, the world's first thinking and reasoning autonomous vehicle AI. Groot, foundation
Groot
models for
1.7.
general purpose robots.
굴2, N2도 지금 뉴
Open
해놨네요.
models for biology, chemistry,
이번에 나오나?
and molecular design.
안 나그래요?
Earth 2, models for weather and climate forecasting, rooted in AI physics. NVIDIA open models give researchers and developers the foundation to build and deploy AI for their own specialized domains.
Our models, thank you. Our models are valuable to all of you because number one, it's on the top of the leaderboard. It's world class. But most importantly, it's because we are not going to give up working on it. We're going to keep on working on it every single day. Nemotron 3 is going to be followed by Nemotron 4. Cosmos 1 was followed by Cosmos 2. Groot at Generation 2. Each and one of these, we're going to continue to advance these models. Vertical integration, horizontal openness, so that we can enable everybody to join the AI revolution. Number one on leaderboard across research and voice and world models and artificial general robotics and self-driving cars and reasoning. And of course, one of the most important one, this is Nemotron 3 in OpenClaw. This is Nemotron 3 in OpenClaw. And look at the top three. There are the three best models in the world. Okay, so we are at the frontier.
오픈클로에서 오프스보다 소넷이 점수가 더 높아요? 그것도 신기하네.
It is also true that we want to create the foundation model so that all of you could fine-tune it and post-train it into exactly the intelligence you need. This is Nemotron 3 Ultra. It is going to be the best base model the world's ever created. This allows us to help every country build their sovereign AI.
네,
And we're
소버린
working
AI
with so many
하는데
different companies out there. And one of the most exciting things that we're
니모트론으로
doing today,
네이버가
announcing
니모트론으로 뭘
today,
하고 있나 봐요.
is a Nemotron coalition. We are so dedicated to this. We have invested billions of dollars of AI infrastructure so that we could develop the core engines for AI that's necessary for all the libraries of inference and so on, but also to create the AI models to activate every single industry in the world. Large language models is really important. Of course it's important. How could human intelligence not be? However, in different industries around the world, in different countries around the world, you need to have the ability to customize your own models, and the domain of the models is radically different, from biology to physics to self-driving cars to general robotics to, of course, human language. And we have the ability to work with every single region to create their domain-specific, their sovereign AI. Today, we're announcing a coalition to partner with us to make Nemotron 4 even more amazing. And that coalition has some amazing companies in it. Black Forest Labs, imaging company, Cursor, the famous coding company, we use lots of it, LangChain, billion downloads
띵킹 머신도
for
있다.
creating custom agents, Mistral, the Arthur mentioned, I think he's here, incredible company. Perplexity's computer, absolutely use it. Everybody use it. It is so good. A multimodal agentic system, Reflection, Sarvam from India, Thinking Machine, Mira Murati's lab. Incredible companies joining us. Thank you. I said that every single enterprise company, every single software company in the world needs an agentic systems, need an agent strategy. You need to have an open claw strategy, and they all agree. And they're all partnering with us to integrate NeMo, the NeMo Claw reference design, the NVIDIA Agentic AI Toolkit, and of course, all of our open models. One company after another, there's so many, and we're partnering with all of you. I'm really grateful for that. And this is our moment. This is a reinvention. This is a renaissance of the enterprise IT. from what would be a $2 trillion industry, this is going to become a multi-trillion-dollar industry, offering not just tools for people to use, but agents that are specialized in very special domains that you're expert in that we could rent. I could totally imagine in the future, every single engineer in our company will need an annual token budget. They're gonna make a few $100,000 a year, their base pay. I'm gonna give them probably half of that on top of it as tokens so that they could be amplified 10x. Of course we would. It is now one of the recruiting tools in Silicon Valley. How many tokens comes along with my job? And the reason for that is very clear, because every engineer that has access to tokens will be more productive. And those tokens, as you know, will be produced by AI factories that all of you and us, we partner to build, okay? So every single enterprise company in today sit on top of file systems and data centers. Every single software company of the future will be agentic, and they will be token manufacturers. There'll be token users for their engineers, and there'll be token manufacturers for all of their customers. The OpenClaw event cannot be understated. This is as big of a deal as HTML. This is as big of a deal as Linux. We have now a world-class open agentic framework that all of us could use to build our OpenClaw strategy. And we've created a reference design we call NemoClaw that all of you could use, that is optimized, it's performant, it is safe and secure. Speaking of agents, as you know,
이제 그루트 얘기하려고 하나
perceive,
보네요.
reason, and act. Most of the agents in the world today that I've spoken about are digital agents. They act in the digital world. They reason, they write software. It's all digital. But we also have been working on physically embodied agents for a long time. We call them robots. And the AIs that they need are physical AIs. We have some big announcements here. I'm going to just walk through a few of them. 110 robots here. Almost every single company in the world, I can't think of one, that are building robots is working with NVIDIA. We have 3 computers, the training computer, the synthetic data generation and simulation computer, and of course the robotics computer that sits inside the robot itself. We have all the software stacks necessary to do so, the AI models to help you. And all of this is integrated into ecosystems around the world, and all of our partners from Siemens to Cadence, incredible partners everywhere. And today we're announcing a whole bunch of new partners. As you know, we've been working on self-driving cars for a long time. The ChatGPT moment of self-driving cars has arrived. We now know we could successfully autonomously drive cars. And today we are announcing 4 new partners for NVIDIA's robotaxi ready platform. BYD, Hyundai, Nissan, Geely, all together, 18 million cars built each
로보택시
year. Joining our
현대
partners
한다고요?
from before, Mercedes, Toyota, GM. The number of robo-taxi-ready cars in the future are going to be incredible. And we're announcing also a big partnership with Uber. Multiple cities, we're going to be deploying and connecting these robo-taxi-ready vehicles into their network. And so a whole bunch of new cars. We have ABB, Universal Robotics, KUKA, so many robotics companies here. And we're working with them to implement our physical AI models integrated into simulation systems so that we could deploy these robots into manufacturing lines all over. We have Caterpillar here. We even have T-Mobile here. And the reason for that is in the future, that radio tower used to be a radio tower, is going to be an NVIDIA Aerial AI RAN. And so this is going to be a robotics radio tower, meaning it can reason about the traffic, figures out how to adjust its beamforming so that it could save as much energy as possible and increase the amount of fidelity as possible. There's so many humanoid robots here. But one of my favorites is a Disney robot. You know what? Tell you what, let me just show you some of the videos.
디즈니 로봇 또
Let's
나와요?
look at that first.
벤츠.
The first global rollout of physical AI at scale is here. Autonomous vehicles. And with NVIDIA Alpamayo, vehicles now have reasoning, helping them operate safely and intelligently across scenarios. We ask the car to narrate its actions,
I'm changing lanes to the right to follow my route.
explain its thinking as it makes decisions,
There's a double parked vehicle in my lane. I'm going around it.
and follow instructions.
Hey, Mercedes. Can we speed up?
Sure, I'll speed up.
This is the age of physical AI and robotics. Around the world, developers are building robots of every kind. But the real world is massively diverse, unpredictable, full of edge cases. Real-world data will never be enough to train for every scenario. We need data generated from AI and simulation. For robots, compute is data. Developers pre-train world foundation models on internet-scale video and human demonstrations and evaluate the model's performance to prepare them for post-training. Using classical and neural simulation, they generate massive amounts of synthetic data and train policies at scale. To accelerate developers, NVIDIA built open-source Isaac Lab for robot training and evaluation and simulation, Newton for extensible and GPU-accelerated differentiable physics simulation, Cosmos world models for neural simulation, and Groot Open Robotics Foundation models for robot reasoning and action generation. With enough compute, developers everywhere are closing the physical AI data gap. Paratas AI trains their operating room assistant robot in NVIDIA Isaac Lab, multiplying their data with NVIDIA Cosmos world models. Skilled AI uses Isaac Lab and Cosmos to generate post-training data for their skilled AI brain. They use reinforcement learning to harden the model across thousands of variations. Humanoid uses Isaac Lab to train whole body control and manipulation policies. Hexagon Robotics uses Isaac Lab for training and data generation. Foxconn fine-tunes group models in Isaac Lab, as does Noble Machines. Disney Research uses their Camino physics simulator in Newton and Isaac Lab to train policies across their character robots in every universe.
올라프 저거 맞아요. 나오던데. 디즈니랜드에 지금 나왔다고. 저거 실물 있는 것 같던데? 이따 보여주려나? 실물 나올 것 같죠? 역시.
Ladies and gentlemen, Olaf. Does it?
Snowman coming through. Pardon me.
Newton
Hello.
works.
Wow.
Omniverse works. Olaf, how are you?
I'm so happy now that I'm meeting you.
I know, because I gave you your computer, Jetson.
What's that?
Well, it's in your tummy.
That's gonna be amazing.
And you learn how to walk inside omniverse.
I love walking. This is so much better than riding on a reindeer, gazing up at a beautiful sky.
And it was because of physics, using this Newton solver that runs on top of NVIDIA Warp, that we jointly developed with Disney and with DeepMind, that made it possible for you to be able to adapt to the physical world. Check that out.
Not to say that.
That's how smart you are.
I'm a snowman, not a snowclopedia.
Could you imagine this? The future of Disneyland? All these robots, all these characters wandering around.
Oh!
You know, I have to admit though, I thought you were going to be taller. I've never seen such a short snowman, to be honest.
Nope.
Hey, tell you what, you want to help me out?
Hooray!
Okay. Usually I close the keynote by telling you what I told you. We talked about inference inflection, we talked about the AI factory, we talked about the open claw agent revolution that's happening, and of course we talked about physical AI and robotics. But tell you what, why don't we get some friends to help us close it out?
Of course.
All right, play it. Come on.
Terminating simulation.
Hello? Anybody here?
The keynote's over, all was said. Jensen mapped the road ahead. AI factories coming alive. Agents learning how to drive. From open models to robots too. Now we'll break it all down for you. Compute exploded what we saw. From CNNs to open claw. Agents working across the land, but they need the power to meet demand. So we solved the problem, it was brilliant. We multiplied compute by 40 million. Once upon an AI time, training was the paradigm. Sure, it taught the models how, but inference runs the whole world now. Vera showed us who's the boss at 35 times less the cost. Blackwell makes the tokens sing NVIDIA. The inference king. Yeah, our factories once took years, vendors pulling racks and gears, built up slowly piece by piece, no clear way to scale this beast. DSX and Dynamo know what to do, turning power into revenue. Agents used to wait and see, now autonomously, but if they ever try to stray, safe claws block and say no way. Nemo claws there to guard the course. And yes, my friends, it's open source. Cars that think and droids that run, this ain't the movies, it's all begun. Alpamayo calls the shots, it's a GPT moment for the bots from sim to streets. Now watch them drive.
이걸 마무리를 노래로 하네요.
For physical AI.
이거 다 제너레이티드라고 딱 얘기하고 끝내겠죠?
Industrial age built what came before, now we build for AI. AI, even more. Vera Rubin plus Grok make the inference splash. Put them together, now it's raining cash. We build new architecture every year, cause claws keep yelling more tokens here. The AI stacks for all to make, so let us all eat 5-layer cake. The moment's bright, the path is clear, cause open models led us here. When data's missing, there's no dispute. We just generate more with compute. Robots learning without flaw, fueling the force, scaling laws. The future's here, won't you come and see? Welcome all to GTC.
All right, have a great GTC. Wave. Thank you, everybody.
Bye, new
See
best
you,
friends
Olaf.
that I just met.
네, 끝난 것 같죠? 자, 그러면은 정리를 하죠. 일단 저도 이제 열심히 보느라고 못 읽었던 댓글 잠깐 보고, 그 다음에 보면서 이제 제가 느꼈던 거 정리를 좀 하고, 일단은 댓글을 제가 잠깐 볼게요. Are you still remaining here, Gauss? If so, I'm gonna talk with you in English. 다음에 제가 새벽까지 네, 감사합니다. 아마 이제 지금 일어나시는 분들이 꽤 계실 것 같은데, 클로드에서 이번에 나오는 코드 검사하는 거 너무 좋아질 듯합니다. 그게 뭐죠? 클로드에서 검사하는 게 뭐죠? 뭔지 모르겠네요. 일단 가우스 댓글 읽어보면, Remember back in university, excited to build and train neural networks for digit record. 그쵸. 처음에 이제 손글씨 숫자 인식하는 거, 그쵸. CNN의 시초죠. 르쿤 선생님이 했던 르넷을 말씀하시는 것 같아요. 저도 이제 그런 거를 했었고, 왠지 가우스는 저랑 나이가 비슷하실 것 같아요. 그다음에 Grok 얘기인데, It seems SRAM is becoming the new standard for latency sensitive real-time inference. 그렇죠. SRAM이 큰 게 지금 중요하다 이런 얘기죠. 그다음에 GPT 5.4 어떻게 생각하시나요? 오픈 4.6이랑 비교하면 제 이번 주 GPT 5.4 열심히 쓰고 있는데 좋은 것 같아요. 뭐 누가 뭐 더 좋다 뭐 이런 거는 좀 잘 모르겠고, 예전에는 확실히 클로드 코드에서 오프스 쓰는 게 훨씬 더 좋았다면, 지금 코덱스에서 GPT 5.4 쓰는 거랑 클로드 코드에서 오프스 4.6 쓰는 거랑 좀 말투나 이런 대화 형식이 좀 다른 느낌이긴 한데 나쁘지 않은 것 같다 이런 생각이 좀 드네요. 저는 최근에 그런 생각하고 있고요. 그래서 좀 열심히 일부러 좀 코덱스 열심히 써보고 있어요 지금. 그리고 이번 GTC에서 그래서 결국 뭐가 이제 중요했냐, 네, 예상하지 못했던 거는 그록이었어요. 그록이 상당히 인상 깊었고, 생각보다 그루트 얘기는 별로 없었어가지고, 네, 이거죠. 디즈니 캐릭터 이거 있었거든요 원래도 티저에.
Hello.
이거 결국 진짜 나왔죠. 이거 디즈니랜드에 언제 들어오나? 진짜 들어오나? 구경 가고 싶긴 하다. 그 다음에 뭔가 영상이 막 나오지는 않네. 네, 여기에 바로 다 올라오진 않네요. 유튜브 같이 보면 좋은데. 엔비디아 검색을 한 번만 해볼까? 지포스에 하나 올라오고, 이런 식으로 나눠져서 올라오는구나. 엔비디아의 채널들에 들어가야 있나 저게? 모르겠어요. 일단 보이진 않네. 미디어 그록 치면 나오겠지? 일단은 뭐가 막 잘 나오진 않네요. 어제 이거 안 그래도 지금 써 있는데 2달 전에 엔비디아 acquires grok 이게 있었는데 결국 이게 핵심이었죠? 메인 제품으로 이거 하는 게 핵심이었죠? 네. 링크드인이요? 저 링크드인 있죠. 그냥 제 이름 치면 아마 나올 텐데 제 링크드인에 막 글을 쓰진 않거든요. 그 링크드인 뭔가 좀 익숙하지가 않아 가지고 일단은 저희는 유튜브를 메인으로 하고 있고 저 그냥 제 이름 치시면 아마 나올 겁니다. 아니면 수도 리무브 그 페이지? 그것도 뭐 있긴 있어요. 뭐 나중에 하려고 준비를 하고 있었는데 일단 귀찮아서 안 하고 있습니다. 자, 그럼 어쨌든 오늘 제가 이제 그냥 메모하듯이 채팅하면서 정리를 했는데 confidential computing 저 그냥 무시하고 저 그냥 립 서비스인 것 같아요. 그다음에 그록3랑 AI 팩토리 이게 좀 저는 중요했었던 것 같고 그다음에는 나노클로 뭐 로보택시 뭐 이런 이야기 있었는데 그러니까 오픈클로 저는 저 리얼딜이라고 생각 안 했는데 이렇게까지 강조하는 걸 보면은 진짜로 뭔가 많이 쓸 것만 같은 그런 생각이 드네. 저는 이제 본질이랑 좀 멀다고 생각했거든요. 그냥 진입 장벽을 낮춰주는. 근데 그게 엄청 중요한가? 이렇게 생각이 되기도 하고요. 자, 그러면은 다시 키노트에 가서 화면을 하나씩 보면서 정리를 하죠. 제가 생각했을 때 제일 중요했던 거. 엔비디아 채널 어디 갔어? 이거. 와씨, 3시간. 왜 이렇게 길었어? 이거는 저거네. 그 키노트가 아니네. 오케이, 이거죠. 자, 여기서 하나씩 마킹을 하자. 이게 이쁘게 잘 편집된 영상들이 하나씩 올라올 텐데 엔비디아에서 자랑하는 게 와, 챕터도 다 매겨졌네 벌써. 챕터 여기 있죠. 챕터 이렇게 띄워놓고 보자. 챕터 어떻게 봐? 이렇게 하면 나오나? 오케이. 페알루빈 이건데
the largest.
한글 자막도 다 달렸네 벌써.
You guys want to do that? Let's talk about Vera Rubin.
이거 이번 거 아니지.
Yeah, go ahead.
투먼
She's a-
떠보네. 뭔가 이상하다 했다. 라이브 키노트 이거죠. 이거는 챕터가 아직 없겠지? 없지. 이거를 제가 틀어놓고 에피페인 여기 깔려있나? 오픈AI에서 오픈클로 개발자 영입했던데 그 피터 여기 있던데요? 아까 진순왕이 샤라웃 하던데? 여기 현장에 있다고 막 하면서 일단 신기했던 거 몇 개는 이거 진짜 돈을 많이 번다. 이거랑 이거 이제 하나씩 하자. 일단은 여기 진짜 없나? 제가 이거 받아놨던 것 같은데? 정리를 안 해가지고 데스크탑 다운로드 없네. 이거부터 받자. 응. 자, 페이지를 하나씩 제가 마킹을 할게요. 지금 이거 어디야? 13011. 이게 그 매출, 레버뉴에 대한 거. 그 다음에는 이제 뭘 팔려고 하냐면, 아, 요거 해야지. 요거 킹 딱 하는 거. 킹 딱 하는 거 요거다, 요거. 예, 이거 개웃겼어요. 14040. 이거랑 이게 이제 무슨 그래프였냐면, 이게 좀 제가 신기했는데, 제가 이제 조금 한번 볼게요. 이거 제가 이 그래프가 맨 처음 봤을 때 조금 이해가 안 됐거든요. 여기서 이제 자랑하는 거, 이거 저 인터액티비티가 TPS per user, throughput이 TPS per 메가와트, TPS per user, TPS per user라 한 사람당 토큰 per sec를 저게 근데 왜 모델이지? 토큰 per sec가 큰 게 왜 모델이지? 고민을 오래 한다는 뜻인가? 저게 그냥 토큰 per sec 유저를 그냥 지능이라고 아까 표현을 하던데, 저거 아까 저기를 한번 가보자. 그 분석 업체? 뭐 그런 게 있었거든요. 이거를 매트릭을 만든 semi analysis, inference X by semi analysis. 이거죠? 베럴 루빈 이거네. 봄이랑 파워 모델. 오케이. 베럴 루빈 GPU 아키텍처 이런 거 있네. 여기 되게 좋다. 한번 볼까? 이거 근데 읽을 수 있나? 읽을 수 있네. 뭐 이런 거밖에 없어요. 이런 거밖에 없긴 해. 뭔가 엄청 자세하네. 리퀴드 쿨링. 오케이. 이거 기억해 둬야겠다. 오케이. 메뉴. 토크노믹스. 왠지 이런 거일 것 같아. 뭐 일단 이렇게. 이거 다시 돌아와서 이거 한번 보죠. 이게 인터액티비티. 지금 기준이 딥식 R1, FP4, 딥식 R1을 기준으로 유저당 토큰이 늘어나면 리즈닝을 많이 한다는 뜻이에요? 그런 건가? 저게 이제 뭘 나타내는지 모르겠어요. 인터랙티비티, TPS per user. 이거 하나만 좀 확실하게 이해하고 싶은데 키 컨셉 TPS per user. 네, 됐고 여기서 한번 보자. 지금 이게 disaggregating serving Blackwell performance on llama. TTFT 저거는 first 토큰이겠죠? TPS per user constraint. TPS per user. (671B) 2초 만에 와야 되고 유저당 12.5 토큰 타겟. 이 타겟이구나. TPS per user. TPS per user. 유저 한 명당 TPS가 커야 된다. GPU 하나. 인터랙티브. 오프라인. 서버. 이게 무슨 소리일까? 딥시크 기준으론 리즈닝 띵킹을 많이 쓸수록 정답 퍼포먼스가 올라간다고 하던데 최신 논문들은 그 반대더라고요. 리즈닝 토킹을 줄여면서 정답을 올리는? 네, 리즈닝이 이제 저도 이제 그런 결과 요새 많이 보고 있거든요. 높다고 꼭 항상 더 좋은 건 아니더라고요. 태스크마다 다 엄청 다르. 낮은 게 더 좋을 때도 많더라고요. 정량적으로 저 바꿔가면서 똑같은 일들을 막 시켜보면은 미디엄이나 로우가 더 좋을 때가 많더라고. GPT 5.4도. 근데 지금 어쨌든 이 TPS per user 얘를 왜 여기서 인터랙티비티 나눠 쓰면 안 된다 이런 뜻이구나. 아. 아. 아, 오케이. 이해했다. 그래서 똑똑한 모델인 거구나. GPU를 고정하면 토큰 펄세크 유저당 토큰 펄세크를 늘리려면 한 큰 GPU 하나에 유저를 한 명만, 두 명만 이렇게 해야 되니까 그게 이제 큰 모델이란 뜻이구나. 오케이. 이해했습니다. 야, 이거 이렇게 하는구나. 인터랙티비티. 오케이, 오케이. 그래서 지금 이런 그래프가 나오는 거죠. 아까 이제 베럴러빈 그래픽스 이거 넘어갔네. 여기서 어디서 이따 찾아야겠다. 오케이. 일단 이게 좀 신기했어요. 이런 개념으로 이걸 설명하려고 한다는 게 좀 신기했고 그러면은 일단 이거는 GPU 기준으로 얘기를 하는 거죠. 하드웨어 이따가 여기서 이제 좀 보여주고 그 하드웨어들을 잔뜩 소개했는데 이거는 뭐 의뢰하는 거니까 이번에도 또 새로운 게 다 잘 나왔다 이런 얘기였고 아까 하고 싶었던 게 이거였어요. 이건데 여기를 그록으로 채운다. 이게 하고 싶었던 얘기죠. 좋아. 이걸 메모를 하자. (20350) 05야? 50이야. 50. 그 다음에 이게 원래 20255 없이 그리고 이 하드웨어 비교 설명이 있었죠? 이것도 신기했어요. 이거를 저렇게 나눠서 쓴다는 게 신기했어요. (20810) 저게 그록 그 같이 쓰기. 그리고 이제 하드웨어 비교가 있는데 이거를 50장을 늘리면 이렇게다. 근데 뭐 55장 저게 중요한 건 아니고 한 장으로 하는 게 더 낫겠지? 한 장으로 비교하는 게 더 이해가 빠르겠지? 이거지. (202) (206) (29) 그다음에 그록 뭐 얘기하는 게 있을 텐데 그록 칩이 있을 텐데 이게 그록이었나? 이거 옆에다 끼우는 거였지. 저게 그록이었죠. 이거 맨 왼쪽에 있는 게 이게 그록이었지. 15000 오케이. 그래서 20350을 보면 이거잖아요.
This interactivity requires enormous amount of bandwidth. Computer exactly the right.
이거잖아요. 지금 이게 보면 다시 한 번만 이거를 이해를 해보자면 인터랙티비티. 그러니까 하나의 GPU를 고정을 하면 이제 싼 모델을 쓰면 인터랙티브 유저 루빈 NBL 72라고 가정을 하죠. 이거라고 가정을 하면 토큰스 TPS per 유저 싼 모델을 쓰면 한 유저당 TPS 토큰 per sec를 이제 50 그러니까 헷갈려. 왜 토큰 per sec 저게 이제 컨스트레인트죠. n명이 나눠 쓴다는 거죠. 그죠? 230빌리언을 n명이 나눴어. 그러면은 토큰 per sec가 50으로 제한해도 돼? 헷갈려. 유저당 TPS가 12.5. 유저당 TPS가 10. 유저가 몇 명인데? 유저당 TPS. 유저당 TPS. 봐봐. 그러면 서버당 72 TPS, 유저당 1000 TPS. 라마4 모델이면 유저당 1000 TPS. 얘는 뭐라고 하냐? Critical metric in LLM inference measuring how fast user receives generated text in. Human reading speed. TPS per 유저는 유저한테 배달되는 거 그거는 알겠는데 유저가 많아지면 로어하다. 모델 사이즈가 GPU를 고정하고 모델 사이즈가 커지면 아니 근데 당연한 거잖아 그거는. 유저를 그 한 GPU에다가 몇 명을 몰아넣고 쓰느냐는 자기 맘이잖아요. 운영자 맘이잖아. 모델이 크면 유저 펄 TPS가 내려갈 수밖에 없는데 얘는 지금 모델이 큰 거를 유저 펄 TPS를 키웠단 말이에요. 생각을 많이 해서 그런 건가? 모델을 키우면 스루풋 메가와트당 스루풋이 떨어진다. 그건 알겠어요. 모델이 큰 거랑 TPS 유저별 TPS가 낮은 거랑 무슨 상관이냐? 이거는 잘 모르겠어요. 왜 이 매트릭을 이걸 썼는지 잘 모르겠어요. 보자. 이것도 한 번만 보자. 인터액티비티. 왜 인터액티비티라는 걸 쓰느냐? per GPU, tokens per sec, per GPU, token per sec, per user. 이거 이제 파레토 프론티어. 이거 공유를 하는 거에 대한 건가? Your challenge lies on the part frontier, the curve that represents the best trade-off between GPU다. TPS. 이거 지금 inference max 이거죠. 아니 당연히 그런 게 이제 공용으로 쓰면은 한 명당 배달받는 건 느려도 한 GPU가 내보낼 수 있는 총 스루풋은 당연히 올라가기 마련인데 모델을 고정하지 않고 왜 여기가 모델이 올라가냐는 거예요. 유저당 TPS가 큰 게 왜 모델이 커지냐는 거예요. 저게 지금 이해가 안 돼. 답을 주세요. 아시는 분들이 있으면 답을 주세요. 왜 저렇게 설명을 했을까? 토큰 펄섹 유저당 토큰 펄세크를 낮추면 트루풋이 올라가지. 근데 유저당 토큰 펄세크를 올리면 트루풋이 내려가지. 유저 한 GPU당 유저가 적으니까. 한 GPU당 유저가 적으면 이거 모델 고정했을 때 얘기고. 모델도 좋은 걸 올리고 한 유저한테다가 GPU 하나를 할당을 많이 해서 더 빠르게 해준다. 뭐 둘 다를 그러니까 모델 고정하지 않고도 그냥 그렇게 얘기를 하나 보네요. 돈을 많이 낸 사람들한테는 더 쾌적한 환경을 제공을 하겠다. 뭐 이런 느낌이라고 일단 생각을 할게요. 제가 이해한 게 맞는지 모르겠는데 그렇다고 가정을 하고 설명을 한번 해보죠. 그러면은 일단 대강 느낌은 잡았어. 일단 대강 느낌 잡았어. 한 유저한테다가 리소스를 할당을 많이 하고 좋은 모델을 쓰면은 당연히 이게 내려가요. 이게 내려가. 근데 딱 이제 모델을 탁 올려놓고 빠르게 토큰을 배달을 시키고 싶은데 유저당 에이펙스를 쓰면은 트루풋이 보장이 돼. 왜냐하면 LPU가 개빠르니까 인퍼런스만을 위한 친구니까. 이게 보통 밴드위스가 문제란 말이에요. 밴드위스가 문제다. 일단 대충 느낌은 알았는데 지금 확실하게 이게 어떻게 달성한 건지 모르겠어요. 근데 자기네들이 뭐 실험을 열심히 했겠지. 자기네 실험 결과겠지. 뭐 좀 자기네들 유리할 대로 쓰긴 썼겠지만 오케이. 일단은 뭐 이 정도 마무리하고 그 다음에 해야 될 이야기가 니모트론과 니모클러. 니모트론과 니모클러는 이제 오픈클러 이야기를 하나 살짝 해주고, 예, 오픈클러 이야기를 살짝 해주고, 이거예요? 이거 아니구나. 그 우주 보낸다 이런 얘기가 살짝 슥 끼워 넣어서 하더라고요. 우주용 GPU. 이거구나. 스타 엄청 많은 거 아까 슬라이드 어디 있었어? 클로콘 이거 한국에서도 했다던데 지난주에. (23610) 오픈쿨러 벤치에서 좋더라. 근데 에이전틱 뭐 이런 거 엄청 강조를 했으니까 그럴 수 있을 것 같아요. 그거는 그럴 수 있을 것 같아. 그다음에 니모쿨러 어딨어? 오픈쿨러가 아니라 니모쿨러. 이 235 오픈쿨러. 이거랑 그래서 뭘 하고 싶은데 하면 우리 니모클로 그래서 했어요. 니모클로 이거죠. 23240 파일스 스페셜라이즈드 에이전트 이거는 이제 좀 잘 모르겠어. 니모트론 니모 다이나모 님 오케이. 오케이 일단 여기까지. 네 대충 하고 싶은 얘기 다 있어. 아 마지막에 맞아. 마지막에 그루트 뭐 올라프 요거죠. 올라프 2495 이렇게 하죠. 이렇게 하면 될 것 같아. 그러면은 하나씩 이제 해보자면 엔비디아가 이제 돈을 진짜 많이 번다 자랑으로 시작을 했는데 결국 얘네는 하드웨어를 팔아서 돈을 버는 거죠. 왜 이렇게 돈을 많이 벌 수 있냐 하면 인퍼런스 킹이기 때문에. 근데 그럼 이 다음 GPU 다음 팔아먹을 GPU 뭐냐 하면 그록이었어요. 오늘의 주인공 그록이었어요. 이 그록은 뭐냐면 LPU 그러니까 랭귀지 모델만을 위한 인퍼런스만을 위한 전용 하드웨어인데 얘네를 이제 인수를 했는데 그걸 가지고 뭐 이런 걸 했다. 위닷 루빈으로는 뭐 이 정도 성능이 나오는데 그록을 하면은 저 정도 성능이 나온다. 어떻게 쓰냐면 저렇게 합쳐서 쓴다. 그래서 이제 TPU 때문에 좀 도전을 받고 있었는데 이런 걸로 헤쳐나가려고 한다. 그 다음 이야기는 오픈쿨러, 니모쿨러 이야기고 니모트론 써봤는데 어쩌고저쩌고 그다음 올로프하고 오케이. 이렇게 마무리하면 되겠다. 자, 제가 이제 오늘 GTC를 보고 느낀 점, 네, 이런 것들 싹 한번 정리하고 오늘 스트림 마무리하고요. 지금부터 찍는 거는 딱 잘라가지고 아마 아침에 편집본이 올라갈 거예요. 그러면은 출근하시는 분들이 보겠죠. GPU 자랑부터. 네, 여기서부터 하면 될 것 같아요. 일단 잠깐 쉬고 좀 마시고 오겠습니다. 화장실 좀 갔다가 돌아와서 시작할게요. 혹시 뭐 댓글 남겨주실 거 있으시면 남겨주시고요. 이거를 근데 제가 이제 녹화를 해야 되나? 그냥 라이브에서 따서 쓰면 되나? 라이브에서 따서 쓰면 되겠지? 이렇게 나가면 화면을 잘라서 쓰면 자, 정리를 해보겠습니다. 네, 지금은 새벽 6시고요. 방금 GTC가 끝났습니다. GTC를 쭉 한번 봤는데 이번 발표의 주인공은 제가 느끼기에는 그록이라는 LPU였어요. 이거에 대해서 한번 살펴보도록 하겠습니다. 젠슨 황 선생님이 여느 때처럼 이 하드웨어를 꺼내놓고 자랑을 하고 있어요. 키노트에서. 근데 이 칩이 LPU라는 칩이거든요. 그러니까 GPU가 아니라 랭귀지 모델을 돌리기 위한 프로세싱 유닛 전용 하드웨어예요. 그래서 이거를 라인업에다가 추가를 했더라고요. 네, 우선 이제 자랑을 합니다. 엔비디아가 돈을 많이 벌고 있다. 그런데 자기네들이 예상했을 때는 0.5 트릴리언 달러를 레버뉴를 했었는데 작년 1년 동안 이제 1년 동안 2배 할 거래요. 더 잘 팔 수 있겠다라는 뜻이죠. 그럼 이제 이걸 뭘 팔려고 할 거냐 하면서 매번 이렇게 자기네 GPU 라인업을 계속 발표를 합니다. 네, 이번에 자랑한 거. 네. 저렇게 자기네들 인퍼런스 킹이라고. 어쨌든 LLM을 인퍼런스 하는 가장 큰 하드웨어 공급사. 뭐 누구나 다 알고 있는 사실이긴 이긴 합니다. 그래서 그런 걸 이제 한번 자랑을 해주고요. 이번에 새로운 라인업이 도입이 됐어요. 그 새로운 라인업은 이 친구입니다. 이제 엔비디아 GPU, 루빈 GPU가 가장 최신 GPU인데 이 친구 말고 그록3라는 LPU, 새로운 칩을 도입을 해요. 이 칩은 좀 달라요. 일단 GPU가 아니고요. 뭐가 다르냐면 이 GPU는 HBM, 네, 우리나라 반도체 회사들이 돈이 많이 버는 이유죠. 이게 하이 밴드위스, 엄청 빠른 22TB per sec의 밴드위스를 가진 메모리인데 메모리 밴드위스가 되게 중요하기 때문에 이런 걸 열심히 달아서 사용을 합니다. 근데 그록은 HBM을 쓰는 게 아니고요. SRAM, 온칩 메모리를 써요. 여기다 프로세서 옆에다가 메모리를 같이 박아버려요. 그래서 SRAM 밴드위스가 훨씬 커요. 차이점은 GPU랑 차이점은 일단 칩 자체가 좀 작기도 한데 플롭스, 이거는 연산, 진짜 컴퓨팅 연산은 GPU가 훨씬 더 크지만 LPU는 밴드위스, 메모리 밴드위스가 엄청 큰 대신에 플롭스는 조금 작습니다. 이거는 오로지 LLM 인퍼런스를 위해서 만들어진 전용 구조라고 보면 될 것 같고요. 그래서 어딨지? 네, 이 LPU를 N개를 55개 뭐 이렇게 되어 있죠. 쫙 묶어 가지고 뭐 이렇게 사용을 하겠다. 밴드위스 크게 사용을 하겠다. 네, 이런 뜻이고요. 그래서 이게 진짜 좋냐라고 하면은 저희가 그래프를 한번 보죠. 이걸 한번 보죠. 이제 매트릭들이 다 스루풋을 메가와트, 전력량을 고정하고 전력량 대비 얼마나 토큰 per sec LLM이 토큰을 쏟아낼 수 있느냐, 이걸 기준으로 매트릭을 봅니다. 이제 황 선생님은 이렇게 작은 모델부터 큰 모델, 네, 이렇게 올라가는 거를 이제 기준으로 봤는데 프리티어를 235빌리언짜리 크웬3라고 가정을 했어요. 이것도 꽤 큰 것 같은데 이거는 이제 취급도 안 하겠다는 거고, 2 트릴리언짜리 GPT라고 가정을 하면 어쨌든 똑똑한 토큰을 쏟아내려면 스루풋이 떨어진다는 거죠. 똑똑한 토큰을 쏟아내면 그걸 팔아서 돈을 버는 거예요. 어떤 토큰을 쏟아낼지는 애플리케이션을 만드는 사람들이 잘 만들면 되겠죠. 어플리케이션 잘 만들면 어쨌든 GPU를 돌려서 그걸 유저한테다 돈을 받고 가치를 파는 건데, 프리미엄, 그러니까 같은 모델이라고 치더라도 뭐 컨텍스트 랭스가 크거나 아니면 한 사람당 더 많은 토큰을 내뱉게 하려면 한 GPU를 한 명이 써야겠죠? 그럼 스루풋이 떨어져요. 왜냐면 공용으로 사용하고 이런 리소스 같이 쉐어하고 이런 게 없으니까. 그래서 토큰을 빨리빨리, 유저당 빨리빨리 내보내려면 스루풋이 떨어지는데 어쩔 수 없습니다. 그런데 GPU만 쓰는 게 아니라 LPX, 그록을 같이 붙여가지고 사용을 하면은 이게 안 떨어진다는 거죠. 특히 좋은 모델일수록. 왜냐면 플롭스보다는 메모리 밴드위스가 병목이거든요. 그래서 HBM이 많이 팔리는 거기도 하고, 그래서 그 SRAM을 아주 많이 갖다 박은 그록이라는 거를 GPU랑 붙여서 같이 사용하면 저 스루풋을 만족시킬 수가 있다. 전력 효율도 좋고 밴드위스도 좋으니까. 이게 이제 다음 제품인 거예요. 요번에 발표한 메인 다음 제품이고, 이걸 어떻게 했냐면 네, 이렇게 구현을 했더라고요. 그래서 GPU가 있고 그록 LPU 여기서 이제 LPX라고 하는데 LPX가 있으면 LLM에 프리필이랑 어텐션을 디코딩하는 거는 GPU를 쓰고 피드 포워드 네트워크 여기에도 이제 풀리 커넥티드 네트워크 그러니까 이런 게 이제 메모리 밴드위스를 많이 차지하는데 이 친구는 그록을 위임을 해서 쓰겠다는 거예요. 이렇게 코워크하는 구조로 만들면은 달성할 수가 있다. 높은 트루풋을 달성할 수가 있다. 네, 그래서 이렇게 이런 렉 더미 이걸 이제 여기서는 AI 팩토리라고 계속 얘기를 하더라고요. 이걸 이제 통째로 세트로 파는 건데 이 AI 더미 팩토리에는 CPU도 있고 GPU도 있고 뭐 스위치도 있고 뭐 많은 것들이 있는데 묶어서 이제 하나의 클러스터로 동작을 하는 거죠. 거기에 이제 그록3 옵션 같은 거를 추가를 해서 이 팩토리라는 걸 파는 개념으로 엔비디아가 장사를 열심히 하는 것 같아요. 팩토리라는 거는 무언가를 생산하는 거잖아요. 옛날에 이제 팩토리가 하나가 있으면 거기서 사람이나 뭐 기계가 있어서 또 물건을 생산하고 파는 거였는데 이제는 얘네가 생산 기계고 토큰을 생산해서 토큰을 파는 거죠. 전기를 써서 토큰을 파는 AI 팩토리. 거기에 핵심 요소 중 하나로 그록3. 특히 이제 인퍼런스 용으로는. 왜냐하면 AI 팩토리라는 거는 토큰을 만들어서 팔 수도 있지만 LLM을 트레이닝하는 팩토리이기도 하겠죠. 근데 LLM을 트레이닝하는 데 쓰진 않을 거고 얘는 아마도 인퍼런스에서 토큰을 파는 용도로서 장사를 하려고 하신다. 이 그록3라는 거는 저희가 사실 저희 채널에서 한번 다룬 적이 있거든요. 한 2달 전쯤에 올해 1월이었던 것 같아요. 엔비디아가 그록3를 인수했다는 뉴스가 있었어요. 그래서 그때도 저희가 이 그록3를 실제로 돌려보기도 하고 왜냐면 클라우드로 저기 사업을 합니다. 진짜 빠르다. 이런 거 돌려보면서 아 신기하다. 이런 걸 알고 있었는데 엔비디아 이런 걸 사는구나. 근데 엔비디아가 그때 이제 '이걸 왜 살까?' 이런 생각을 했었어요. 그때는 제가 어떻게 생각을 했었냐면 이 GPU만으로는 안 된다. 왜냐하면 GPU는 인퍼런스 전용 하드웨어가 아니기 때문에 트레이닝에도 쓰고 그래서 되게 범용적이고 좋은 하드웨어지만 인퍼런스를 엄청 많이 돌리려고 하면은 그렇게 좋지도 않아요. 왜냐면 태스크를 스페셜라이즈하게 좁히면 당연히 전성비도 올라가고 뭐 여러 가지 장점이 있으니까. 근데 그런 관점에서 경쟁자 중 하나 떠오르는 칩들이 많이 있어요. 우리나라의 어떤 NPU 칩들 회사들도 마찬 그런 걸 타겟으로 하고 있죠. 뭐 리벨리온이나 퓨리오사나 그런 회사들도 있고 우리나라만 하더라도 뭐 글로벌하게는 세레브러스라는 회사도 있고 뭐 여러 개 많이 있습니다. 그런 회사들. 그다음에 제일 큰 경쟁자 중 하나는 사실 구글의 TPU예요. GPU, 엔비디아 GPU가 아닌 제미나이 학습시키고 제미나이 인퍼런스도 다 하는 TPU가 있어요. 참고로 TPU는 트레이닝도 하는 하드웨어라서 조금 경계가 모호한데 어쨌든 엔비디아 GPU가 아닌 다른 LLM을 위한 하드웨어들이 이제 막 나오고 있단 말이에요. 그중에 하나였고 그록도. 근데 엔비디아가 그중에서 그록을 사서 이렇게 합쳐져서 코워크를 하면서 더 좋은 걸 할 수 있는 그런 솔루션을 내놨다. 저는 이번 GTC에서 가장 주인공? 네. 진짜 예상도 못 했는데 그록이었었네요. 그다음에 다른 이야기들도 많이 했는데 2분 25초. 네, 다음 이야기는 화제의 오픈클로예요. 오픈클로가 이제 GitHub 스타를 진짜 많이 받았다. 짧은 기간 안에. 그만큼 사람들이 엄청나게 좋아한다. 이런 이야기였는데요. 오픈클로 말고 뭘 발표했냐면 니모클로라는 걸 발표했습니다. 네, 이거예요. 니모클로. 그러니까 오픈클로가 어쨌든 오픈 소스고 아무 LLM을 저희가 사용을 할 수 있어요. 뭐 오픈클로 때문에 요즘에 뭐 맥미니가 동이 났다 뭐 이런 얘기를 많이 하는데 맥미니를 사람들이 많이 사서 쓰려고 하는 이유는 사실 맥미니 안에서 LLM을 돌릴 수 있기 때문이잖아요. 그래서 이제 보안 문제가 없이 내 컴퓨터 하나 딱 셋업해서 거기서 이제 갇혀 있는 외부로 데이터가 나가지 않는 그런 머신을 아마도 운영하고 싶은 수요가 많기 때문에 맥미니가 많이 사용이 될 텐데 LLM을 사실 밖에 있는 클라우드 사업자 거를 쓰려면 그냥 뭐 라즈베리 파이 이런 거 써도 되거든요. 사실 뭘 써도 상관없어요. 그런데 그렇지 않은 경우가 엄청 많죠. 특히 회사 같은 경우에는 우리 데이터가 6시 반이라서 알람이 울리네요. 우리 데이터가 밖으로 안 나가길 원하는데 그럼 이제 내부에다가 이런 걸 다 꾸미길 원해요. 그런 하나의 레퍼런스 구현체 이런 식으로 하면 돼라고 하는 거를 엔비디아가 좀 자랑을 하고 싶은 것 같아요. 그중에 하나 니모클로인데 왜 오픈이 아니고 니모냐? 엔비디아에서 밀고 있는 자기네 LLM이 니모트론이죠. 그래서 자기네 GPU를 사거나 뭐 자기네 클라우드를 쓰면은 자기네 LLM까지 다 쓰면은 니모트론을 이용해서 오픈클로의 니모 버전, 니모클로를 쭉 다 셋업을 해주겠다. 이런 견본품을 보여주는 것 같고요. 제가 지금 갑자기 생각이 났는데 이거 거의 똑같은 게 있어요. 뭐가 있냐면 키미클러라는 게 있습니다. 키미에서도 키미클러라는 걸 만들어서 내놨거든요. 이것도 이건 사실 편집된 영상 나간 적은 없고 저희 라이브만 한번 했었는데 제가 키미클러 써보는 거를 키미에서 저희한테 쿠폰을 주셔가지고 한번 써봤는데 키미클러도 똑같아요. 그냥 버튼을 누르면 빈 컴퓨터 하나를 딱 줍니다. 그다음에 거기다 이제 키미가 붙어서 돌면서 그 컴퓨터를 다 컨트롤하는 거예요. 오픈클로가 깔려서 키미랑 연결된 컴퓨터를 파는 거죠. 비슷하다고 볼 수 있을 것 같아요. 네, 그리고 여기서 니모트론에 대해서 자랑을 하나 좀 하는데 니모트론 3 슈퍼가 지난주에 나왔습니다. 저희가 이것도 리뷰 영상을 하나 올렸죠. 왜냐하면 저희가 엔비디아에서 사용해 볼 수 있는 권한을 좀 받아가지고 제가 테스트를 한번 해봤었는데 참고로 니모트론은 3가 나노가 있었고요. 30빛짜리 이미 예전에 있었고 이번에 나온 게 120빛짜리 슈퍼가 나왔고요. 500빛짜리 울트라가 지금 학습 중이라서 올해 상반기에 나온다고 합니다. 근데 니모트론 3 슈퍼 얼마나 좋냐라고 하면 여기 오픈클로에 끼워 넣어서 사용을 해봤을 때 오픈 모델 중에는 제일 좋더라 라고 지금 엔비디아가 자랑을 하고 있네요. 1, 2, 3등은 클로드 모델이랑 GPT예요. 근데 신기한 거는 1등이 오프스가 아니라 소넷이에요. 소넷이 오프스보다 더 좋네요. 이게 좀 하나 신기한 점이었던 것 같고 일단 니모트론 제가 개인적으로 써본 평가? 네, 체감상 평가는 뭐 어떤 구체적인 수치나 이런 건 아니에요. 그냥 제가 대화를 한번 해보면서 저는 참고로 오픈클로에 껴서는 안 써봤고요. 오픈 코드에만 껴서 한번 써봤어요. 코딩에 한번 써보려고 했기 때문에 이제 GPT 5.4나 오프스 4.6 저는 이런 걸 구독해서 쓰고 있기 때문에 그런 거보다 막 엄청 좋다 이런 거는 사실 당연히 그렇게까지 느껴지진 않았고 그냥 오픈 모델들 크웬 3.5나 이런 친구들이랑 그래도 견줄만 하다. 물론 크웬 3.5는 더 큰 모델도 있고 뭐 더 작은 모델도 있고 그래요. 그렇지만 오픈 모델들 중에서는 나쁘지 않다. 이 정도의 저는 체감 성능이 있었고 재밌는 거는 니모트론은 어떤 학습 데이터라던가 트레이닝 레시피 이런 것들을 많이 공개해서 저희가 배울 점이 되게 많은 그런 모델 중 하나라서 앞으로도 좀 기대가 되는 모델이고 특히 500B짜리 그 안에 내용을 보면은 에이전틱한 걸 어떻게 하면 잘 쓸 수 있을까 그런 걸 학습시키는 거에 대해서 되게 열심히 이제 뭘 해놨는데 그러니까 이제 오픈클로에서 꽤 좋은 성능을 보일 수 있었다. 네. 이런 게 이제 재밌는 점이었던 것 같아요. 키미 K2.5 저런 거 분명 1트릴리언 이렇게 10배나 큰 모델일 텐데 그런 거보다 점수가 잘 나왔다는 게 좀 신기하긴 합니다. 네, 그리고 마지막으로 지난 디즈니 그 스타워즈 로봇에 이어서 이번엔 디즈니 올라프 로봇으로 만들어 가지고 나왔어요. 얘 자랑을 어떻게 했냐면 옴니버스, 그러니까 아이작에서 걷거나 보행이나 이런 거 다 학습을 시킨 다음에 그거를 이제 실물 로봇으로 딱 올려주면서 시뮬레이션 세상에서 배운 로봇이 실물로도 요렇게 이제 돌아가고 있다. 이런 걸 진짜로 딱 잘 보여준 것 같고요. 저게 이제 바이럴이 되고 있는데 아마도 디즈니랜드에 진짜로 곧 돌아다닐 것 같아요. 이미 돌아다니나요? 모르겠네요. 그래서 요런 거 보여주는 걸로 마무리까지 완벽했다. 그리고 이제 자세히는 안 나왔는데 뭐 재밌었던 게 몇 개 조금 더 있었어요. 그루트 N1.7, 그루트 N2 네, 나오는 것처럼 얘기를 했고, 그다음에 GPU 우주에다 써서 보내서 우주에서 데이터 센터 운영할 거다. 뭐 이런 이야기도 좀 있었고. 네. 요렇게 GTC 제가 본 감상 후기 네, 마무리하겠습니다. 네, 채팅 지금 주셔 가지고 읽어 보면 비싼 모델을 쾌적하게 서비스하려 그쵸. 펄 유저당 토큰 펄 세크. 네, 비싼 모델을 만족스럽게 서빙하려면 원가가 엄청 많이 든다. 그쵸. 왜냐하면 한 GPU를 한 명의 유저한테다가 데디케이트드를 줘야 이제 쾌적하게 되는데, 어쨌든 적은 유저가 쉐어해야 그러면 이제 스루풋이 팍팍팍 떨어지니까, 그런 상황에서 원가가 35배나 더 좋다. 네, 그건 이제 엄청 극단적인 케이스를 아마도 가져와서 비교를 했을 텐데, 어쨌든 네, 그런 내용이었던 것 같아요. 원가는 그래서 전기료당 토큰 펄 세크, 쾌적함은 유저당 토큰 펄 세크, 비싼 모델은 프리미엄 모델, 네, 큰 모델, 그다음에 뭐 큰 프리필, 네, 컨텍스트 렌즈도 큰 거, 뭐 이렇게 했던 것 같아요. 네, 맞아요. 흥미로운 거는 프리필과 디코드를 나눴는데, 그쵸. 전에는 프리필이랑 디코드만 나눴었는데 그렇게 하는 게 아니라 프리필에 디코드 어태치드였나요? 어텐션 아니었나요? 제가 잠깐만요. 다시 한 번만 볼게요. 네, 이거 디코드 어텐션. 네, 어텐션 디코드인 것 같아요. 어텐션은 저 풀리 커넥티드보다 메모리 밴드위스 제한 같은 게 적으니까, 왜냐면은 저 웨이트들이 다 저 FFN에 있잖아요. 그래서 그거는 그룹으로 넘겨서 하는 거였는데, 어쨌든 이렇게 나누는 기준을 좀 바꿔서 네, 저런 방식으로 최적화해서 나누는 것까지 아이디어가 좋았던 것 같다. 네, 저도 뭐 비슷하게 느꼈습니다. 루빈 CPX 아이디어, 저 그거 뭔지 모르겠네요. 그거 페라 루빈이니까 루빈에서 뭐 나눠서 쓰는 그런 게 있었나요? 일단 제가 CPX라는 거 지금 처음 들어보고요. 아마도 저 그록 3를 붙여서 쓰는 게 판매 옵션일 것 같거든요, 엔비디아 입장에서. 그래서 그록을 안 살 수도 있을 텐데, 왜냐면 모든 경우에 저게 다 필요한 건 아닐 테니까. AI 팩토리라는 걸 꾸미는 어떤 클라우드 사업자 생각해 보면 자기네들이 서빙하고 싶은 모델이나 자기네들이 타겟 어떤 쾌적함, 유저 쾌적함 이런 것들이 다 다를 거라서 뭐 용도에 맞게 그록이 없을 때도 있을 테니까 예전에 있던 기술을 뭐 폐기하진 않았을 것 같아요. 무조건 저렇게만 그록 같이 꼭 사야 된다 이렇게 팔진 않을 것 같아요. 아마도요. 네, 협상하기 나름일 것 같습니다. 네, 일단 오늘 여기까지 하죠. 6시 40분이네요. 네, 굿. 제가 7시에 운동을 가려고 했는데 이게 생각보다 너무 늦게 끝나가지고 운동을 못 가겠네. 네. 저거 해야겠다. 우리 맨날 이런 거 안 했는데. 자, 오늘 발표한 그록 3 니모트론 슈퍼. 저희 영상 이미 다 다룬 내용들이거든요. 저희 채널을 구독하시면 이런 소식들을 미리미리 받아보실 수 있다. 구독하세요. 오늘 마무리하겠습니다. 수고하셨습니다. 이건 그냥 툭 잘라가지고 바로 저 편집본 영상으로 올라갈 겁니다.